My name's Macy McCuller, and today I'll be talking to you about how you can upgrade your tools with Python states. Before we get started, a little bit about me. I'm a technical artist in the games industry and a Texas A&M alumni. I've been working in Houdini for about 5 years now, and about half of that time has been spent in some sort of professional setting. One of the things that initially drew me to tech art was the support aspect of the role. I really enjoy working with artists to help them solve problems, improve their workflows, and support their endeavors with tools. This pursuit is actually what drew me to Python states to begin with. So here's a quick overview about what to expect from this presentation. We're first going to talk about what viewer states are. Then we'll break down how a Python state is structured and how to set up a state using the viewer state code generator. From there, we'll use what we've learned to walk through an example of how you can create the viewer state to your right. At the end, I'll share a few more resources on how you can continue to learn more about Python states. Please keep in mind that this topic can be quite broad, and I'm condensing a lot of information. This talk is targeted towards those with an intermediate to advanced understanding of Houdini. Additionally, we'll be discussing some Python concepts, so be prepared for some code. With that in mind, I don't want to overwhelm you with having to hurriedly take notes or retain everything right now. So I'll have a link to these slides and the demo HD at the end, so you can review them after the presentation if you so desire. So to begin, we're going to start by looking at something you should all be pretty familiar with. Here, I'm entering in and changing the values in the parameter pane to scale, rotate, and transform this box. It takes a bit of time, but it's pretty simple to manipulate the shape of the box in this way. However, if we move our mouse over to the viewport and press enter, you'll notice that a set of handles appear. These handles are a part of the box node's viewer state. Now we can move, rotate, and scale the box just by interacting with these handles instead of having to change the values by hand. As another example, I've modeled a spring and I want to be able to bend this spring from side to animate it. I've placed down the bend node to help me with this task. I could go into the parameter pane and find the 5 or so values I need to change to bend the spring. Instead, though, I could just go over to the viewport, press enter to access the bend node's viewer state, and this fancy little green handle appears. Here I can move this back and forth to get the perfect angles to set my keyframes. And then we have attribute paint. If we move over to the viewport and enter its viewer state, attribute paint allows for painting and erasing attributes directly onto a mesh. In addition to being able to draw, I'm able to scale the brush with the mouse wheel and switch brushes with a menu that comes up when I right-click. Attribute paint is powerful and allows for a lot of art direction when used, but it would not be functional without the interaction in the viewport. So, what is a viewer state? It is an interactive user interface that interprets user input such as mouse clicks or scrolls, key presses, or handle movement. When these specific events occur, the viewer state will execute the related code contained within event handlers. You can actually implement custom viewer states with Python. As an example of this, in the GIF to the side, I have a handle that is attached to a sun object that is being moved around the viewport. The flowers in the scene are moving to grow towards the sun. So, what are some of the advantages of custom states? Well, first off, they're custom tailored to your tool, so you can add whatever interactivity that would best suit your goals. They will also allow for more art direction. In the instance of attribute paint, the state is allowing you complete control over the paint through the state. And then Python states can also be more intuitive for the tool user. In my case, I work with a lot of artists. Most of the time, they're hopping in and out of modeling and animation software, game engines, and all sorts of DCCs. They have different levels of familiarity with Houdini and may not be as comfortable with trying to find the right values to make the tool work perfectly. Building a custom state for your tool can make your tool more accessible for the people using your tools. Directly interacting with the mesh or moving handles around is going to be something that every artist will understand. So my understanding of the code structure of a viewer state breaks it down into 3 main parts that are all housed within each other, not unlike these Russian nesting dolls over here. So the Python state is held within a Python file. The Python file contains a class called state that is interpreted by Houdini for your viewer state. Within this class, Houdini is expecting explicitly named callback functions known as event handlers. These callback functions are triggered when a variety of specified actions known as events occur. An example of an event would be when you click the mouse or press a key on the keyboard. Event handlers contain creator-implemented custom code that will be executed when the corresponding events occur. To reiterate, the state class contains the event handlers, and the event handlers execute your code when certain actions happen. When it comes down to it, the majority of the time, we only need to worry about authoring the code contained within event handlers. As far as event handler functions go, there are a lot of them, so I'm just going to briefly explain the broad categories of event handler and what you can do with them. Lifecycle handlers deal with the startup, shutdown, and interruptions to the state. UI event handlers are the broadest category, and these will handle activity from the mouse and keyboard, but will also handle right-click and context menus. Handles are, you guessed it, used to implement handles such as from the box demo we saw earlier. Selection is going to allow you a similar functionality as the selection interactivity in something such as the group node, being able to quickly select points, primitives, or edges. Drag and drop allows for the ability to drag files or other items into the viewport and process them. And then drawables are one of the more unique features when it comes to Python states. Think of drawables as a form of fancy guide geometry with some extra bells and whistles you can play around with. So most viewer states are tied to HDAs. So to set up a state, we'll first need to create an HDA. From there, we'll open up the node type properties, go to the interactive tab, and then we can open up the viewer state code generator. SideEffects has done an awesome job with this and made a really handy interface so you can easily select all the event handlers you need, hit a button, and then it will generate the Python file with correct imports, class, and all the event handlers you selected. So you can just jump right in and add your code. So to walk you through this, we're going to take the HDA that we want to attach a viewer state with and hit right-click on it, hit Type Properties. From there, we'll go to the Interactive tab. We'll hit the button that says New, and a window is going to pop up. This is the viewer state code generator. And let's take a closer look at it. So upon opening it, you'll probably want to first add a label and a description for your state. Then you can add any event handlers you think you'll need by hitting the checkboxes. The event handlers are broken down by category to help you maneuver the interface, but the ones I reach for the most are going to be on enter, on exit, on resume, and on mouse event, and we'll be going over those in detail in a moment. SideEffects has also included samples. Samples are jumping off points that will select related event handlers to that specified function. So if the keyboard sample is selected, all the event handlers related to that particular function will be selected. You can select a sample and then check additional event handlers down below if you wish to do so. Once you've added everything that you want, you can hit accept, and the viewer state code generator will generate your code. You'll now see the state script within the interactive tab. This here. So another thing is you can actually edit the code directly from that window in Houdini, but for larger endeavors dealing with a lot of code, I actually prefer to use an external text editor. So Side Effects has made this really, really easy to do. Once you have the generated code, you can just right-click on your HDA, go to Edit External Section Source Code, select the viewer state module, and then hit Accept. The code will open in your preferred text editor. Additionally, Houdini will watch the file for any updates, so you can save and update the PI file directly in the text editor, and those changes will be reflected within the HDA. Here's kind of a broad overview of what the code that the code generator generated for us will look like. You'll have a couple imports, and then we have the class that houses our state. Contained within this class, the class is all the event handlers we selected from the code generator, along with a couple extra pieces to help us get started. The code generator also adds a function outside of the state called Create Viewer State Template. This is the function that's connecting our viewer state to the viewport. For today, the default Create Viewer State Template will suit our needs just fine, so we won't be modifying it. But in the future, if you're implementing things such as handles or menus, you'll have to bind them here. So for our example today of how to actually implement a state, we're going to walk through a simple custom state that uses the mouse position and clicks to place spheres on an input collision. Additionally, color will be assigned to each sphere depending on the type of click. To do this, we're going to first make the HDA, set up the node contents and parameters for this task, and then generate the code. We'll then initialize some variables in the init, such as the custom collision object, and then update the collision in the onEnter and onResume event handlers. Additionally, in onEnter, we'll be talking about and setting up our info panel so we can display instructions to the user on how to interface with the custom state. Most of the heavy lifting will be done by the onMouse event handler, getting the position of the mouse and assigning points with left click, adding red, left click plus shift, adding green, and middle click, adding blue. We'll also briefly touch on how you can cleanly undo each action. So some of you may be questioning why I'm assigning functionality to the left and middle mouse buttons, but not right click. There's actually a limitation when it comes to right click with viewer states. If you're working with geometry, such as in our case, and you right click while the mouse is over that geometry, instead of being handled by mouse event, it actually opens up a geometry context menu, nullifying the action. There's a couple more rules that you may have to work around if you want to use right click, so I usually opt to stick to left and middle click. As far as our HDA goes, the contents of the HDA tied to the state are pretty simple. I have a multi-parm that is going to represent our points. Each instance of the multi-parm will have a position value and a color value tied to it. So we'll have position 1, position 2, color 2, so on and so forth, with each pair representing an individual sphere. As far as the contents go, I have a wrangle that is creating the points from the positions and color parameters, then copying spheres to those points. The internals are pretty straightforward, but pay special attention to the null node I've named collision surface. This is the node that we'll be using to reference our collision object. Now we'll generate our code by using the state code generator from earlier. We just need to add onEnter, onResume, onInterrupt, and onMouse event today. And here's the code that the code generator would spit out. we can now implement our code within those event handlers. So the first thing we're going to be implementing is the required code for geometry intersector. So this is a class from the viewer state utilities that allows us to snap our points to our collision object. If you feed in the mouse position and a piece of geometry into an instance of geometry intersector, it will return whether or not it finds geometry underneath the mouse, the position where the mouse cursor and geometry intersected, and what primitive was under the cursor when that check was made. So here we are implementing the geometry intersector code in our init. Additionally, we'll want to talk about implementing an info panel, also known as a HUD or heads-up display. An info panel is going to be the UI at the top left of the viewport that gives instructions or information to the user about how they can interact with the viewer state. The HUD is structured as a Python dictionary with specific syntax that Houdini is expecting to be able to read in and create the info panel. So for this example, onEnter is, in this example, all we need to do in our onEnter is take those variables we initialized in the init and set them to the correct values. So when we enter the state, we'll grab that collision right off the bat. I'm going to be grabbing the geometry from the collision surface null node we used earlier and then feeding that into our geometry intersector. When I do this, I'm also caching the geometry with freeze. I consider caching geometry for this a best practice type of thing, and while it won't greatly affect our system today, there are some cases where your collision could change or update while using your viewer state, which is why I prefer to cache it most of the time. Additionally, we'll also want to attach our HUD directory into the scene viewer. For our onInterrupt and onResume event handlers, which these are going to be called when you move the mouse out of the viewport and then change some parameters and then move back into this viewport, onInterrupt will be called when you move the mouse out, and then onResume will be called when you move the mouse back in. So for example, all we want to do is just recache the input geometry so geometry intersector can read the correct collision. We have to do this in onResume, so if someone leaves the viewport and changes their input mesh, then we can check and recache that geometry, so we always will have the correct geometry being used as collision. On mouse event is where the bulk of everything is going to be happening within this example state. On mouse event is called when the mouse interacts with the viewport, oftentimes when moving and clicking. So there's kind of a lot here, but I've broken it down into chunks. So the first thing in our mouse event is we're going to want to grab the mouse pointer and get the ray that mouse is casting. We can then feed in the values from the mouse ray into the geometry intersector. So we can get the position of where the ray from the mouse hit the geometry and what primitive was hit. It is important to note for later that if there is no geometry underneath the cursor, the primitive that we'll get will be registered as -1. From there, we need to get both device and reason. Device, in this case, is what buttons were used during the callback. Reason is how the mouse was used. So was it a click? Was it were the buttons being held down or was it released? From here, we just want a simple mouse click. Once we have both the reason and the geometry intersection, we can then check to see if those two conditions are met. We'll ask if the mouse is both hitting geometry and if the mouse was clicked. If so, we can then determine what buttons were used with the device. Once we've determined the button used, we're going to then add to the multiparm. To do this, I've created a helper function to help us out. First, the function adds one slot to the multiparm and then sets the position and color values for each point. We can then use this helper function to add points by feeding in the color and position values. Houdini will automatically add things to the undo stack as you update parameters and interact with the view state. However, if you want one set of actions, you can place the code within an undo block. So these commands enter the stack as one item. This can save on the repetitive instances of using Control-Z. In our case, because we are setting 3 parameters each time we add a point, each addition would require 3 undos. But if we wrap the code that adds each point into an undo block, we are able to reduce that down to one single action. Once we've done all of that, we have a state that will allow us to left-click on a mesh and place a red sphere, left-click plus shift for green, and then middle-click for blue. The info panel in the left corner displays the information to the user. You'll also notice that if we swap the input to the pig head, we'll be able to click directly on him and add points, but we won't be able to click where the grid used to be. So we worked through a very simple state today, but if you want to learn more and want more examples, Houdini has a pane tab called Viewer State Inspector that you can open and to browse all the viewer states currently accessible to Houdini with the path to the code so you can open them up and see what the author of those states did. Here's a few more resources that helped me learn Python states. And then, as promised, here's a link to the presentation where you can also download the HDA. The QR will handle all of that as well. But I thank you for your attention, and I hope you enjoyed this presentation and maybe learned something as well.
Hello, my name is Jonathan Formosa, and this is my presentation on plant growth effects and more within Houdini. And I'm representing the Houdini User Group for Scotland. So because the presentation is on plant growth, I will kick off by showing you my demo reel, and you will probably guess which project it is I'm talking about. Now, when approaching a project that I have no idea how to do, I always start with these sketchbooks, or this idea of like a sketchbook. I usually create a new Houdini file, and that file is just for experimenting, nothing else. It's not it's separate from the main project file, so that if it breaks, it's absolutely fine. I mean, Houdini's procedural anyway, so that doesn't really matter, but it just keeps everything in a separate place to have a file to experiment in. Now, these GIFs that I'm showing you here are experiments that I've done on different projects. You can see when I was trying to learn how to do the plant growth in this particular file. This isn't very clean, but it's not polished, but it was a way of experimenting different methods, which were then used in the final project. Same with these mushrooms, experimenting how to get the mushrooms to die and things. Chains, smashing light bulbs, all that stuff. It's not polished, but this is just a way to experiment. I highly recommend doing this on any project where you have absolutely no idea what you're doing and you just need a way to experiment different methods. Now we will take a look at the plant growth. So to start, you'll want to source some high quality plant assets, or you can make your own. I used Quixel Bridge to source the plants. This is one of the plants that I used. I have a few variations of this plant. So I'm going to go over a newer version of the plant growth tool that I've created since making that project. This is a more improved and cleaner setup than the one I used on that project from some things I learned along the way. So I'm going to show you. Firstly, I sourced these plants from Quixel's Mega Scans, although that's not around anymore, so you can probably find those same assets on Fab. All you need is a plant asset. So here I'm taking the plant asset in, and I've created this subnetwork here where I've broke everything down. So I'm unpacking the geometry and then going into this rigging setup where I need to find the normals of the asset so that I know the direction of each point, scattering lots and lots of points onto this, and then using a connect adjacent pieces to create connections between those points. I'm then using this function here to group the point that's closest to the origin, because this is all centered at the origin, this plant, and this will create our root group for our find shortest path, which will find a hierarchy path between each point from the root, which I've selected, and to every point that is not the root. I'm then fusing these points together just to clean it up, using a poly path to clean it all up and make it the one line, and then regrouping the root as point 0 so that we keep a hold of that, using this orient along curve, which will find the orientation based off the normals which we created earlier, so that it knows where each line is positioned and its orientation to the next line. The rig doctor will then help us convert this into a rig, and then we're promoting this distance to our maximum distance, max distance, so that we can find the maximum distance that this plant can grow. Now that we have the rig, we're going to plug it into, we can get rid of that. We can now go into our animation section where I created these index attributes. This essentially, I'll visualize it here, is just so that I can offset the timing of each leaf. So I'm just creating indexes that I'm setting manually. So each leaf is a different index, which I'm then using to offset the time here, so that each leaf grows in at a slightly different time. I'll just show you all the vex for that. I'm creating the time shift here, and then that's just going to take the index and randomly offset it. Then I'm going to create a mask here using the distance attribute that we had before. Let me just show you that. So this mask is taking a progress attribute, which we made here, which is just fading over time from 0 to 1. And this is then being multiplied by this distance attribute so that over time the distance will go from the root of the rig to the ends of the rig. And then using the rig attribute wrangle, we are transforming the orientation of each bone with that mask. I will show you the vex for that here, so you can copy it for yourselves. And that is how we get the animation. And then using a bone deform, sorry. We take the rig, the animation, and the geometry, and we start to transform it. We deform the original geometry with the animated rig, and we get our plant animation. Now it's time to look at caching and instancing. So first things first, once we have each animation for the plant, this is all using the same process that I just shown you. We want to cache out each plant as an alembic. The reason we use alembic is because then the alembic gives us subframes for free. There's going to be no issues when it comes to retiming, and we can use the set prim intrinsic and vex to start driving this animation later on. Then we want to create a mask with points. So this is the area in which I'm allowing plants to grow, and I've created this mask which I've just animated pretty much just using a point in the center, and then using an attribute transfer onto these other points and just creating a mask from that. It's pretty simple. You can do it however you want. In some scenarios I've used the sort of burn tools in Houdini, the pyro source spreads, things like that, just to, as long as you can create some sort of mask, you're absolutely fine. Once we have all the plant animations, we need to instance our plant animations to the points with the animated mask. We're going to use the mask in here in a attribute wrangle to drive the animation using the set prim intrinsic. In this example, I've looked at the frame range of the animation, which for the plants I've had 200 frames. The first 100 frames are the plant growing, the second 100 frames are the plant dying. And I'm looking at which frame I want the plants to start dying and the frame rate. This is just so that I can control the speed of the plants dying and the speed of the plants growing differently. Using the random influence that I've set up here, this will allow me to control how much variation there is between the plant animations. And that's so that I can change it. So I want the plants to grow in at different times, but all die at the same time. So I'm controlling that through these two random influences. One is for the plants growing, one is for the plants dying. So after that, in a lot of iterations, you should get something like this. So as you can see, they're all growing in at different rates, but they're dying at the same time. So that's what was going on. It was quite difficult to do this, and to figure this out, at least for me. But after a lot of trial and error and a lot of iterations, you kind of see the final result here. Lighting and rendering and comp. So for lighting and rendering, I used completely Karma XPU. Everything was composited in Nuke, and the render times took about 5 to 10 minutes a frame. You can see here I've created a new LOP network for every single shot, every camera angle. I don't know if that's the best way to do it, but that's how I did it for this project. I also did some sketchbooks here, testing different things. So this is how the sort of average Karma network looked. I really liked using Karma because I could group things, so I could group my lighting setups here. I could just copy that into another shot, group the setup for the plants, etc. It was really quite brilliant, and it allowed me to do some cool things with AOVs for this project. So, lighting rendering comp, you can see the final shot, a final still render looked like this. However, I managed to separate out the light passes in Karma so that I could separate them out in Nuke, add them back together, and then I could actually animate the lighting in comp. To do this, on each light, you want to enable the LPE tag and label your lights different things. For every label, you'll have a different light pass. And then on the beauty pass, split per LPE tag. And this will just give you this will separate out your light passes. So here I've got a spotlight or key light, my gobo pass, and my HDRI. They're all separate passes because I labelled them HDRI, gobo, key light, and then I got these different layers in Nuke. I suppose you could comp this in Houdini as well. A few extra things to quickly look at. The final push of the project, 20% of your time is spent on the setup, and 80% of the time is spent cleaning things up and refining and revising the shot. This whole project, on and off, I spent for about 9 months. Roughly, it was about 9 months. On and off, that's not full time looking at it. That's just, I was also doing uni as well. So, yeah, 20% of the time is setting up the shots and 80% cleaning up and revising things. Adjustments and fine tuning, all done manually. As you can see here, I've separated a lot of things out, deleted things. Try and see your effects in context as soon as possible. So seeing your plants growing on their own are brilliant, but seeing them grow as a group will tell you a lot more. Create rules and systematic vegetation with noise and patterns, and be patient. This whole thing takes a while. A quick thanks to Jason for asking me to do the presentation. My mentors from when I was part of the Access Mentorship Program, Joshua and Hudson. Thank you for listening to my presentation. If you want to contact me or reach out about any questions or any work or anything, these are the ways to contact me: Instagram, LinkedIn, my email. I do appreciate it. Thank you for listening, and thank you again for the Scottish Houdini User Group allowing me to do this talk. I appreciate it.
In this presentation, I'm going to talk about VQVDB, a deep learning powered compressor for volumetric data. It's a very fancy way to say that it compresses and decompresses OpenVDB fog volume. My name is Enzo. I'm a software engineer freshly graduated from university and working at AWS. In my spare time, I do research in machine learning and GPU optimization workflow for Houdini. I recently started a project called VQVDB, which is a technique that compresses volume using machine learning. I posted a quick video on LinkedIn and it went quite well, so I'm going to show you this video now so you have an idea of what VQVDB is. In this presentation, we will talk about the current state of VDB compression and VDB file format, such as NanoVDB, NeuralVDB, etc. I will then talk about VQVDB internal working, how does it perform, what kind of performance we can achieve, I will also do a live demonstration using Houdini SOPs that I implemented, and then we will talk about the future for artists using this kind of machine learning tool. Let's talk about the current state of VDB. The industry standard is OpenVDB. It's using a sparse tree approach in order to divide space and reduce to dense 8x8x8 voxel called leaf. It can produce very heavy file cache, especially for sequences, achieving easily terabytes or tens of gigabytes for smaller VDB sequences. The creator of OpenVDB created NanoVDB, which is a linear form of OpenVDB, especially useful for GPU. It adds quantization, which is some sort of compression, and can reduce up to 3 or 4x the footprint of the file. NeuralVDB is created by NVIDIA and used neural networks at different levels in the hierarchy in order to achieve huge compression ratio, but it's very slow to compress and decompress, and it's not fully open source, thus not really usable for artists. Let's introduce VQVDB. It starts from a weekend project after watching a video about variational autoencoder. It's a machine learning technique also used in generative AI in order to create new image from a datasets. There's a variant of variational autoencoder called vector quantized variational autoencoder. It's used in VQVDB and aims at reducing VDB file size while maintaining a responsive enough compression and decompression time. It's open source, available on GitHub, and the paper is also available on Fixture. The paper is not up to date as there were significant changes in the architecture since, but it gives a pretty good overview on how the technique is used and applied to VDB. Since this tool is designed for artists, I wanted to make the most simple possible pipeline in order to compress and decompress VDB volume. As you can see, there is only two nodes, one encoding and one decoding. You can simply input the VDB into the encoding, it will compress the file into a .vqvdb format on disk, and then you can use the decoding node in order to pick that VQVDB file and decode it straight into Houdini. Let's open Houdini and see how that works in practice. Okay, so we're in Houdini, let's compress a VDB sequence. Start by creating a geometry node. We can then import a file that contains our VDB sequence. The entire sequence is 129 frames long and weighs 720 megabytes. Let's import. It's a bit sideways, so I'm going to transform it first. Oh, wrong. There we go. Okay, it looks good. What's in the volume? Just the density field. Voxel size is 1, so nothing to change, it's pretty standard. Let's use the VQVDB encoder. These nodes use the file name, which will be appended at the end of the output path for each file. I specify the $F here in order to change the frame number, which will convert this to a VDB sequence. The batch size is the size of the batch that you want to pull in the GPU. I use a 1080 Ti, so in that case, since it's a small VDB volume, I will use 124. You can push this parameter as far as you want, as far as it doesn't exceed your VRAM. Let's connect this. I want to encode the frame range. For this demonstration, I will encode 72 frames. So let's set 72 here. Now, we can just click here and click the button Encode and Save to Disk. It will pop up a little Houdini console window with which you will see each frame being compressed. You can also follow here. Each frame takes around 162 milliseconds in order to be compressed. Now, let's watch on disk. We have our VDB sequence here, and then we have our VQVDB sequence. As you can see, frame 71 weighs 350 kilobytes. If we look at the VDB, frame 71, 6,616 kilobytes. It's a huge reduction in file size. Now, let's use the decoder. The decoder takes an input the VQVDB file. So we can go look to our VQVDB, show sequences as one entry, and pull that. The batch size works the same way as the encoder, so let's put 124. We can now see our decoder decoding the VQVDB file live. We can then press play and watch the decoding happen in real time. Let's take the frame, this one. Great. Now, if we want to compare this and our ground truth set here, or here, it's the same one, we can just set a switch in order to be able to visualize them more easily. Let's switch between the two. You can see little to no difference, which is what we want. Let's get a bit technical now. So VQVDB uses machine learning technique. It means it has to be trained. For each dense leaf in a VDB volume, I run different convolution, channel attention, and residual block steps. Then I create a latent space with 128 dimensions. This space will pick up every detail in each leaf. The training step then compares the input leaf to the reconstructed leaf from the latent space and compute a neurometric, usually MSE or LS1. The autoencoder will after that optimize its latent space in order to reproduce a leaf as close as possible to the original. The entirety of VQVDB has been trained in a single GPU, a 1080 Ti, and it uses approximately 50 to 60 gigs of RAM. The compression comes from the discretized latent space. With 256 entries, it fits in a single byte. Let's say we run convolution steps on the leaf and reduce the 8x8x8 to 4x4x4 and keep a single byte in each. We have 32 bytes per leaf, with which we can have near lossless reconstruction, with a 32x smaller memory footprint. The training can easily be done within Houdini using PyOpenVDB to extract leaf data and PyTorch to execute the whole machine learning algorithm. The training process exports an ONNX file, which can be then loaded into the custom C++ application. Houdini is shipped with ONNX, meaning that you can use your GPU and CPU in order to compress and decompress volumes as fast as possible. Now let's look at the quality. So in this A/B comparison, we can see the Disney Cloud full resolution, which is on disk approximately 2.3 GB. If we switch between the two, we can see absolutely no difference. I promise you that those are two different renderers. I know that the render is a bit noisy, but let's look at the next image, where we can see in details that there is very little to no difference. You can see on the left side we have our VDB. When loaded into Houdini, it weighs approximately 3.8 GB. It's loading in 16 seconds on my SSD using Windows. I rendered only a small part where we can see different details, some very dense area and also very wispy and low density area on the bottom. I zoomed in the low density so you can see how it looks. On the right side we have VQVDB. On disk it weighs 138 MB. It loads in 13 seconds. Now you may wonder, how can it load quicker than the VDB one? As I showed in Houdini, we can specify a batch size. Depending on your GPU, it's much faster to load data from the CPU to the GPU than from the SSD to the CPU. Since VQVDB is very small, it can entirely fit in the GPU in one step and then be streamed and decompressed in real time. So it's visually identical and dramatically lighter, at least on disk. When loaded and decompressed, it should be around the same size in RAM as the original VDB. Why did I build VQVDB? Nowadays, I believe that freelance and amateur artists have some kind of gamer workstation, meaning that they have big GPUs. It's almost necessary when working with Houdini or any other tools. GPUs are becoming faster and faster, which tremendously helps the decoding of VQVDB. Since VQVDB file size is smaller, it's also way easier to send them through network. As you can imagine, VQVDB is in very early development stage. You can check out the work being done in real time by checking the GitHub page. As a reminder, VQVDB is open source. Some of the current work includes sequence encoding that can reduce up to 100x VDB file sequence by using temporal coherency. This does not include any machine learning or AI algorithm, similar to what codec like H264 does. Before finishing this presentation, I would like to thank all the early testers of VQVDB. Without them, I wouldn't have been able to solve all the pesky bugs and distribution issues I had.
Hello everybody, my name is Damien Kessler. I'm the founder and VFX supervisor at Working VFX Studio. Today I'm going to do a small presentation to show you how the studio works, what we do, and how Houdini is making all of this possible. To talk a little bit about my background, I graduated from ArtFX 10 years ago in 2015. It is a school in the south of France. Then I worked in Paris in multiple small studios, then moved to Montreal to start my FX career at MPC. You can see part of the demo reel that I created while working at those companies. After a few years working in different companies in different countries, I went back to France to start my freelance journey, and that's where I started to directly work with clients as per continuing doing some studio work as well. 2023, after more and more freelance projects coming in, requiring more time, more technical and challenging shots, I decided to create a studio to be able to push the client's vision further by being able to bring more people on board. The studio is physically located in the south of France, as it is where I'm located, but it is only based on remote workflow because I like the idea that everybody working with us could choose where they want to live and not especially need to move to crowded cities with heavy public transport, sometimes abroad and far from their families or friends. Basically, I want this to stay their choice. Now, what do? We started by mainly working on video clips or short films. Then we got into some commercial works, then TV series, and finally started to get some feature films. Today, our work is mainly TV series, feature films, and a bit of commercials. I'd say we specialize in CG integration with real footage, creature work, and of course, FX as well. I'm going to play our demo reel right now, and I'll come back to talk about the pipeline and Houdini.
Yeah. Picture us whipping in the ladder, head out the window, foot upon the gas and head off the pedals. We some diamonds, but they calling us medalists. Skip the comments, cause it's not in my element. Guard is up when we attack. Armored hearts is not the only thing cracking. When we come soaring out the hatch, we like the forest scorching, not the match. Mind your business till the business is done. All this wishing it ain't really enough. All that's missing is the motion. We too busy toasting, infinitely filling it up. 2020 vision bringing in dubs, and we ain't going for the gold. We breaking necks and going for the throat. Don't gotta check us, now you bout to know. It's my rebellion, my power, now I'm burning bright. It's my rebellion, people trying to roll my right. It's my rebellion, tear the chains, pull off the chains, and I walk my own way. It's my rebellion. I got distance to take. Pressing pedals, put the revenue. Perfect timing by resisting the way. Looking down on us, but we got ahead of our time to bring it to the age. You reminiscing soon as we engage. We see the hate and we see who amazed. Half of them leaving shame. Either way is my hunger appreciate. On the run with them hunters, so keep away. Better turn on my brothers, you'll see the bank. Cause there won't be another when we in place. We been putting our all to see the change, and we only gon' fall if we arrange. We see the law, we see the chains, and that's the only time you gon' see them break. It's my rebellion, my power, now I'm burning bright. It's my rebellion, people trying to roll my right. It's my rebellion, tear the chains, pull off the chains, and I walk my own way. It's my rebellion.
Alright, now let me talk a bit about the studio. In terms of scale, we fluctuate between 2 and 9 artists with an average of 4 artists per project. Our pipeline is quite flexible. We work locally with a syncing process which allows to share the project, renders and scene files. We use Prism as our file structure manager, Kitsu as our project manager, especially in big projects, ZBrush and Substance Painter for asset creation, Maya for animation, Nuke for compositing, and finally Houdini is our main CG package. We use it for layout, FX, fur, crowd, CFX, assembly, lighting, and rendering with Solaris and Karma. Now we're gonna have a look at 2 projects. The first one is from a short film called From Human to God. You can find it on YouTube. And it was very challenging because we had a lot of character animations to do. We had creatures to create, a few environments to replace as well. So here's the scene. Now we're looking at Prism, where we can see all of the sequences and shots. We can see the scene files and all the media. Here you can see the animation made in Maya. We're reviewing the playblast. This is the beauty renders that we can find in Prism as well. And just a QC check so we can make sure everything is all right. Here's the final compositing. We'll dive into the scene now. We are now in Solaris and you can see how the scene is made. We'll start from the beginning by getting the camera, getting the environment that has been done by another department. We import the lighting for the sequence. Here we have a light rig where we just add some more clouds. We do 2D clouds so it directly affects our environment. We get into the camera and we can see what we have at the moment. All right, everything looks okay. Can continue. Here we get our Minotaur character. Just for the purpose of visualization, I'm gonna turn off this material. Okay. Later we'll bring the animation here on top. We also do the effects of the nose ring. We then have the option of either using a simulated fur or a deformed fur or just the original fur. This will be applied using the Houdini procedural at the end of the script here. We isolate the characters on this one. Going to activate the shader again and just render. Looks like that. If we go to the other side, we'll have the environment where we had our 3D crowd displayed only with planes, so it's faster. We have flag simulation, we have Karma Fogbox, and we do a fast render. It's going to be blurred anyway. And that's the result of it. So this is how we set up the scene. Also, you can see most of the heavy layers are optimized. And that's it for the first scene. Here we have the QC render part. Let's see the second scene. That second project we're going to have a look at is a video clip called Holy Water. You can find it on YouTube as well. This is the plate we got. The obvious difficulty is the very long frame range. So it is 2500 frames. What we want for the first part is to have all of that foreground cliff to be a cemetery of guitars, where we can see they already put 2 of them on set, and we just want to have a bunch. So that's what we're going for. We start with getting that foreground cliff from a photogrammetry made from the backplate. We can then create different scatter options from patterns, random, from painted areas, or from feature. Or in this case, we want all of the ambient occlusion areas to get affected so we can stack guitars. And this is what we got with all of our points. We'll then add p-scale, add random orientations, and then this is our out. And here we have a preview using boxes, just so we can have an idea of the coverage. Then we move to stage area. And here we can import all of our different guitars already made in USD. That's probably a better way to do that, but it works. We merge them together. Everything is scaled to the correct wall space. And then we put that into an instancer where we got our points and an offset of the p-scale. This gives us all of the guitars for the scene. We import the camera, the cliff, the lights from the scene, and then we use Karma XPU to be able to render that. We will come back to this later to add more close-up guitars at the top of the cliff. Then second part, and this is a big one. On this one, we have created a ground and roughly matched the geometry so we can get proper collisions. The idea is to have water coming from behind, splashing onto those hills, mountains, and then flowing towards the camera. So by the end, it can splash directly on our foreground cliff. That's a bit of a mess. On this side, we have custom velocities. On here, we do everything that is collision-wise. We also do here, using boxes, simplified collisions. We will do a first flip solver. So with the flip simulation, here we bake it, so we can watch it from here. So this is our baked simulation with points. That took a few hours, obviously, but it wasn't that long. It's just that obviously the frame range is a bit long. Then we curl some points just to get something faster or lighter. On the side, we also work on individual splashes that we do separately, just to have more control. So the first splash is that one. Then the second one will be a splash over this mountain. We can then retime them to place them accordingly. And the third one is the close-up one. Then we have everything merged together. We have a custom meshing, so we mesh all of this together. Once it is cached, it looks like this. So this is curled from the camera view. Then we have on this side white water source. So we use a few points to create white water based on vorticity and speed. We do a first foam simulation using points. And then from the points, we'll do another one with Axiom Solver to do a smoke simulation. On the second part, we work on that close-up simulation that will hit our foreground cliff and be our final explosion. We will apply the same treatment where we create white water and then a smoke simulation from it. We can now go onto stage and be prepared to render. Okay, you will see a few errors just because this is out of frame range. So this is our ocean mesh that we import. We'll then add our white water as particles and our foam simulation as smoke. All of this together, we put some shaders onto it, and then we can add the camera, the lighting, and the environment to be a matte object. Let's see from the camera view with the backplate on. And let's hit render. Nice. This is looking pretty dark, but just remember, we're supposed to get AOVs out of this and rebalance everything in compositing. And last but not least, lightnings. So once we're done with the two previous effects, we just do a small comp, put it in there as a backplate, and time our FX lightnings to hit with the music. We manually place all of our points, we give it a start frame, create the branching system, apply the lightning noises, and then once we give it the P scale, it will create the animation. We can then apply some more changes like width breakup, give it the width, actual width of the rendering, and erase all of the points that we're not using directly. Then we go onto stage mode. This is the last part. We import the lighting geometry. We give it an emission shader, transform this into a light, add the camera view, and then just hit render. And this is the result once it's all comped together and we apply grade onto it. Now for the last part of this presentation, I'm going to show you the tools we built to be as efficient as possible with our pipeline and on our project. We've created LOP imports, exports, renders. So with the LOP import, we are able to access everything that we exported. Could be our asset, could be our animations. Then we merge them to get them together. And as seen previously, we can apply the fur back onto it. Once we put a light on, we can now render. The export node is to output anything as USD. It could be directly your scene, or it could be within a department, for example, exporting your light rig as a shot, as a sequence, or as an asset level. Loop render allows you to quickly render your EXR sequence using the farm or locally. The next tool we created is called Hermes. It is our LookDev HDA. Plug in your character and you can set up your render with your turn. Use it with different lights, different presentation, different cameras. Set up the asset rotation as per the light rotation. Get some wedges, including clay renders, and get your MP4 mosaic already done as a return. Last one we created is a material library. Plug in your materials and it will be automatically set to the material you selected. Here's another part of our Hermes, is the Hermes Studio. Instead of using HDRI, use our custom studio. Choose within the materials that are already made. And by giving your asset the name of the material, you can already apply it automatically. This is not made to be a final asset. It just allows you to quickly get your scene going. Now, I would like to take a minute to thank Side Effects for the awesome software, all the new features, the great support that we get. And I would like to thank all of the persons that have been with me from the beginning, helping me develop that studio and create kick-ass images, great workflow and pipeline as per very cool custom tools. Thank you everybody for watching and see you next time.
Hey everyone, my name is Victoria Werner. I'm a Houdini artist from Austria, currently based in Vienna, and today I'm gonna show you my setup for a simple character creator in Houdini. First, I'm gonna show you how to procedurally model the character. Then I will go over creating the skeleton based on the curves that we already have. Then I will do a quick overview over rigging the character with Apex. And lastly, I will show you my HDA setup and how I did some character variations with that. So I'm not originally from a character background, but for the KNEF X week for this year's Houdini challenge, I thought that it would be nice to have something simple that I could play with and do some poses and build some scenes. And then I saw the mega character tutorial by Christopher Rutledge and I decided to try build something similar, but instead of drawing the character, I wanted to create it based on curves and points. So this is what the final character looks like. I divided the whole workflow into modeling, skeleton creation, rig setup, and animation testing. And this is what the setup for the initial character creation looks like. So the first step was to set up the base shapes. The body is just a simple sphere that I transformed and deformed. And the only other thing I did here was to match the height with my legs. The leg is just a simple line where I offset the point that will become the knee. And then I took the tip of the leg and offset it and merged it back in again to form the foot. The next step was to sweep the line, and I also added a bevel to form a stronger shape for the heel. Then I clipped the bottom of the foot to make it flatter, and I also created a group that I will use later on. With this procedural setup, I can now easily go back and change parameters, like for example the length of the legs or the spacing, as well as the length of the foot or the width of the legs. I created the arms the same way I created the legs, offsetting 1 point for the elbow. For placing the arms, I created a line that I rayed onto the geometry of the body, and then I selected 1 point to copy the line of the arm onto it. For the fingers, I created a circle and I rayed the tip of each finger onto it, so now I can procedurally change the length of the fingers. Same as with the legs, I now have full procedural control over the arms and the fingers. I can change the length or the placement on the body, as well as the thickness. For the nose, I modeled a base geo, but I still tried to keep everything as procedural as possible in order to be able to change things later on. For the nose to align with the geometry of the body, I created a bounding box, and then I created a second box that is based on a line rayed onto the body geometry, so that I could use a lattice deformer for my nose geometry. Here you can see again the parameters that I'd like to expose later to change the appearance of my character and create variations. The eyes are also super simple. It's just a sphere for the eyeball and a sphere for the pupil. And for the placement on the body, it's the same setup as for the legs and the arms. The only difference here is that I enabled the point intersection normal so that the eyes are oriented along the normals of the body primitives. Another thing is that I extracted the centroid for each eye to use later on for the skeleton. To merge the eyes better with the body, I created a brim that is placed based on the centroid of the eyes. The ears are also just a simple base geometry, and the placement works the same way as the arms. For the mouth, I used a simple curve and added some teeth, and since I wanted to keep the setup very simple this time, I decided to use a switch with different mouth geo inputs to choose from. The next step is a very short one. Here I just combine all the base shapes and I check if I'm happy with how the character looks so far. Now I'm ready to refine the shapes and to give the character some clothing. The refining process is just a simple VDB workflow. Afterwards, I use a quadrimesh to get a better topology for the rigging, and then I just set up the colors that I want for my character. I do the same for the eyes and the teeth, and I give every element of the character a name attribute to use later. In the first pass of the setup, I simply used clip notes to get the shape of the clothing, but I quickly realized that this would break the proceduralism if I change, for example, the body height. So instead I used a bounding box and Boolean intersect, and the rest is again a VDB workflow. As you can see here, the bounding box is not only a better option because it is 1 node instead of 4, but it also adjusts with changes that I do on the body, and you can easily change the dimensions of the clothing. And now all the other elements of the clothing are created in the exact same way, so the entire setup really just consists of a few main recipes that are repeatedly used and adjusted for each component. You can also see this here, where I decided that I also wanted my character to have some hair, so I copied the setup I did for the arms, and I created another line to control the bend and orientation of my hair geo, and then I modeled a simple braid and used a path deform to place it onto my curve. For the main hair section, I took the top part of the head and added some noise, and then again ran it through my VDB conversion, and I also gave my character a headband. Now I'm doing the same step as before, where I merge all the elements of my character together. I check if everything looks clean, and then it's time for rigging. This part is based on a tutorial series by Max Rose, so I will rather quickly go through it, but if you want to take a more in-depth look, make sure to check out his videos. I start by creating a proxy G of the body, and since I haven't yet created a base curve for the body skeleton, I'm doing that here as well. Every point gets a name, as well as tags that I'll use later for the apex setup. And the last thing I do here is create some control shapes. Then I do the same for the legs, but here I already have my curve from the modeling step, so I'm importing that one, assigning groups, names and tags, and of course make sure to mirror the whole thing in the end. The arm is exactly the same. I import my curve from the step before, and one small thing I changed here was the way I assigned names to each bone. Previously I did that with a wrangle, but here I used the name node and it works exactly the same. For the fingers I also used the curves that I already set up, but I shortened them here for the skeleton, as one half of each finger geo will form part of the palm of the hand when they are merged, so I only need the first 2 points where each finger can later be moved separately. Then I create the bones for the eyes from the centroids, and then for the hair I again use the curve from before that I initially used to control the transformation and deformation of the braids. And so by setting those up in the beginning, I don't only have control of the modeling of the character, but I also already created a base for the skeleton, and this comes in handy every time I want to make changes to the character's appearance. So now I have all my proxy geo, skeleton and control shapes, and then I set up the remaining parent relationships for my skeleton hierarchy. And the last part of the skeleton setup is the skinning. I do this separately for the eyes, as I'm later creating look at controls, and I don't want the body to move with the eyes. And then here I'm simply testing if everything works correctly. Now the character is almost ready for the apex rig. I just delete some of the attributes that I won't need later here. I parent the eyes to the rest of the body, and I check if all my tags are there. Then I create the guide skeleton, which is just points that I use to later build the center of gravity and global controls and so on. Now I'm gonna go a little bit faster through this one. There are a lot of really cool tutorials on Apex out there. For my character I made simple controls for the body and hair, and an IK and FK setup for the arms and legs with a switch between the 2 modes. And as I mentioned before, a look at control for the eyes. What I did not include in this character setup are blend shapes. That's why I made the switch for different mouth types, and as I'll show later, I gave the character various outfits. So for the final scenes, I just switched between different outfits and facial expressions. And after that is done, I export the character and rig, and I load it in again to test the rig and set up some poses. And these are the final results for the Houdini challenge. I made 1 pose for each day of the motion week, and I built a small scene around the character. And with this setup, you can create all kinds of characters. Here, for example, I made a mouse. The only thing to keep in mind is that if you want the skeleton and rig setup to work right away, you need to make sure to keep the bone structure as is. Otherwise, the apex setup can't find certain bones and will break. Here, for example, I kept the curves for the hair, but instead of braids, I wanted the character to wear a bow. And now if we test the skeleton, it should work. But if you want to make other characters, like this gentleman right here, or maybe switch it up a bit and make an animal sidekick, you can use the setup as well. but you will have to tweak the skeleton and rig, as for example the nose of the character has additional bones, but this can also be done very quickly, so it shouldn't be too much of an effort. And of course you can also build an HDA from the setup. Here I made the base shape for the body my input, and I exposed some parameters of the nodes that I previously marked red. So mainly all of the curves that drive the different elements of the character, and then I played around a bit with different proportions and colors. And if you build in a switch between the low poly and high poly versions, it becomes really fast to test different looks. Okay, so now a quick recap of what I did. First, I modeled some base shapes for the character using curves, and then I procedurally placed them on the body using points. Then I refined the shapes by running them through VDBs, and this is also where I set up the clothing and hair. Next, I used the curves from the modeling pass to create the skeleton, and I set up name attributes and tags, which I use later in Apex. But before going into Apex, I set up the guide skeleton, and then I used the rig script components to build my character rig. After that, I import my rig into another scene to test it out and to build small scenes with my character. And lastly, I built an HDA out of the modeling setup in order to create multiple different characters. Learnings. So one small detail that you might already know from rigging in another software is that a slight bend in the knee and elbow really helps later on in orienting the joints, and it also facilitates the setup of the pole vectors in Apex. Another thing that I came across was the naming of individual fingers breaks the rig, and that can easily be fixed by just naming all the fingers the same. And lastly, I found that not everything works right out of the box. Like here I'm having some issues with the shirt after changing the body shape, but since everything is set up procedurally, I can dive in and adjust the bounds, and I can also promote these parameters for better access for when I need to do changes the next time around. Same here with the nose. I have some issues with the VDB part, as there is a little gap between the nose and body geo. So I'm again diving inside, dropping a transform node, and then after tweaking the distance, I can promote the parameter as well. And yeah, that's it for the simple character creator. Thank you so much for tuning in.
Hi guys, today I'm gonna show you how to animate this kind of nice detailed character that you can see here, our ballerina. And it's a metahuman, body-wise at least. And so we're gonna walk through loading out the metahuman, animating with Kairos.ai, which is the service I'm developing with my team that is doing motion from a prompt. And then we're gonna even go at the character with all its bells and whistles, you know, hair, cloth, etc., and checking how this works. So let's drop in our lob network. And the sub create just to load our character. So the metahuman import character rig is what we're after. These are the new Houdini 21 Metahuman plugins that I have installed. So let me load up the right one. So I drop in the folder with the Metahuman over here, and I get a character. So it is getting loaded up as an Apex character. You can see here the Apex character format packed in a packed folder. So let me first put it in an Apex scene. Just because, you know, the Apex tools are made to work with a scene. So let's name it my dude. And then we have an apex scene that has the character and the scene graph. So now I can do stuff with it. So let's maybe first just animate it in the apex usual way. So I have a scene animate, and I can hit the viewport state and auto key maybe. So maybe let's make him wave or something like this. Extremely quick animation, but sorry, I'm not gonna have time to put any time into this, but just for a demo. So yeah, this guy is now animated, and you can see there is motion, but Houdini is still in the time independent state. Everything is inside the apex scene. So whenever I'm ready to move to rendering, I can do a scene invoke, which is gonna do all the apex work and spit out a classical Houdini scene. But this one is now gonna be, yes, it's not independent, but still is packed. So then I need to say unpack folder. And I will be needing the base, because this is the shape of the character without rig, without controls, without skeleton, etc. And I'm gonna do a trail just because I like to have some velocity, so not dependent on the caching in the Solaris graph. And that would be an output. So now back to into Solaris, I can hit the autofill materials. There is some issues here with the normals, maybe, I'm not sure, but the XP is rendering it fine. So if I maybe drop in a light, just because I'd like to see something a little bit nicer, and give it a little bit of a image-based light. You see my Metahuman is rendering, is animated, no arms are waving, it has velocity, so it's gonna have motion blur and everything. Okay, that's great, it looks good, but this way to animating it might take a while. So where Cairos comes in to help is giving you this prompt-based motion. So let me drop in the Cairos client. Here's the HTA, and I'm going to go and log in. And then I'll see Electra, because I've chosen it to be the preview character. And there is a couple of other motions that I have tested out earlier, but let's say now, okay, wave high, and I'm going to hit send prompt. So as we wait for this to work out, how Cairos is, how the whole thing is working out. So we have a bunch of motion capture that our team is doing daily, and we're describing the motions, and they go into a database that is AI searchable. And then when you talk to the chatbot, it can search in the database, it can find stuff, you can have a conversation with it. It's smart enough to figure out that, for example, you're talking about several motions. Let's say you say look left, look right, and cross the street. It's going to know that these are 3 different motions. It's going to make the sequence, and then it's going to give you the result. So it's not generative AI in the sense of creating the motion using AI, but it is AI in the sense that, you know, it looks up in database and does cool stuff like sequencing your motions, retargeting to your character, building skeletons of characters automatically, etc. So you can see that, yeah, we have the waving high motion. You can have lots of fun with this. You know, the more context you give it by chatting to it, the more cool results you should be getting. And eventually the vision is that this becomes something like a virtual actor. So you can just talk to it and then you get it to do the stuff that you have in mind. Okay, so to retarget now to the Metahuman, I'll need the Cairos Apex retarget. Because the Metahuman is an Apex, there is also a retarget node which is KineFX. So now let's hook things up, and I will just rename my character here to Metahuman because there is a little bit of a bug in there. So I reconnect these, and what happens in this node is that the KineFX animation is getting retargeted to the Metahuman skeleton, and then it's getting injected into the Apex scene. So if you look inside, you see that there is a unpack where the skeleton is extracted from the Apex scene. Just the right controls are picked up. There is a traditional rig match pose and map points. And then in the editable subnetwork there is a full body IK, and it's editable just because you might want to go in and here and modify stuff. You might want to create some rig poses or whatnot before and after. I here have made the weight on the feet bigger just to make sure they get anchored, this kind of stuff. And then after the animation from skeleton is putting all the animation into the Apex in a specified name, clip name and frame range. So you can see here I have some kind of a wave already going. Okay, this was much easier, obviously. And then I can plug back into the scene animate, and I just want to fix the actually make another scene animate. Because I just want to fix the arms that were going kind of behind in a little bit of a weird way. And if I hit enter here, and if I go into the state, you see that anytime I select a control, I have a track full of keyframes, and this is just because the layer of animation that is coming from Cairos is just like what comes usually from motion capture. It's baked keyframes. So to make an adjustment, I need to add another layer. So if I open up the Apex Animation Layers tab, and I say I want this guy, and then I hit the button create a new layer from the selected controls, I'm going to have another layer, and in this layer I'm going to be able to do a little bit of an offset, and maybe for the other hand I can right click and I can say add selected controls to layer, so I can have one more control added to this layer, and then if I play it back I'll see that the arms are a little bit spread out. So otherwise this is the same as before. So we invoke the scene, and I just need to correct my path here. Actually I can even use a wildcard like that, and moving back into my LopNet I can see that guess if I turn in the camera. I should even get some motion blur going. I guess I need, to set it up correctly. Okay, so I just had to turn on the velocity blur. I'm not sure why, sucker for motion blur. So yeah, there you go. We have easy animation of this base Metahuman character, and this is pretty good. But this is just a guy without, this is just like a part of your asset usually. So in a real situation, you need to have the clothes, the hair, and so on. So here we can talk about the Cairos rebuild service. So what that is that it's a human in the loop, which means basically there is an artist over there. So you can give it a simple concept. It can be a crude 3D mesh, it can be an image, and they would build and return to you a production ready asset, which means the clothes were modeled and the hair was done. Also, clothes are in Marvelous, ZBrush, hair is in Houdini. So you get a USD which has the Metahuman as its component. So I have one ready over here. Let's say a sublayer. Which is our ballerina from the example. So here is the file. And that's how it looks. So you can see there is the base Metahuman, but there's also clothes, there's hair. So you can animate pretty much the same way, but you can also add the CFX after. And to get that going, I can go into my subcrate again, and instead of loading the Metahuman here, I'm gonna check out the asset, and there is a files primitive with a Metahuman attribute, and I can say show me that file, and it's a zip file that you can simply unzip and you get a folder with the Metahuman. So this is something that you can load up in the Metahuman character rig HDA. So when it's done, I will have again, the same motion, but with my ballerina character, and then I can just ask Kairos for give me your best ballet move. Here you can be very general, like you're talking to a friend. It doesn't need to at all be. I haven't misspelled it, obviously. It doesn't at all need to be something very specific. Unlike using keyword searches or stuff like that. So I get a result like this back. Quite nice. Balletic, maybe. How is it pronounced? I have no idea. Then I can proceed, to do whatever my custom edits. If you have done anything in the scene animate, of course, the whole thing is going to be baked, so you have to reset it. I think I just reset it in advance, but anyway. And yeah, you can check out the result in the subcrate. It's kind of going to be the same. But that's one layer. obviously you need, all the other layers, the hair and the cloth, which is some vellum work that we're not going to have time over here, but I have baked a layer with that, all that stuff done, and we can check it out quickly. So once you have everything done, let me know if you guys want to see how the vellum of these layers is made, because yes, it is kind of cool. Hopefully you're gonna get, this character that has cool dynamics. Again, check out the animations over here. So yeah, some cool dynamics, and it's done very easily. Once you set up the CFX, it becomes quite quick to change animations. So yeah, this is quite a quick workflow, and I think especially if you again use Cairos to create a skeleton and scaling for your character, or if you just do it straight in Houdini, you could use these crude AI designs to test some characters very quickly, and then once you are ready with a particular design, you can then rebuild it to get to a production level and end up with your cool animations quite quickly. So thanks a lot, and let me know if I can help with anything more.
That is fresh new faces. Glad to be here. Thank you for Side Effects for having me here. Just a quick self-introduction. But okay, today I'm going to talk about Houdini's procedural power across industries in the real-time age. So essentially, right, because the thing is, I think we've seen a lot of presenters. It's really wonderful work. We see a lot of beautiful effects, a lot of media and entertainment and things like that. But how about across industries, across other aspects? So a quick introduction. I own a training company called Radiant 60. We are Unreal Authorized Training Center. And myself, I'm Go Unreal Authorized Instructor Partner for Epic Games. And I'm also Radiant 60 is also a training center partner at sideeffects.com. And something new from Side Effects, they actually launched at SIGGRAPH, I think, a program called Houdini Certified Instructor. So very honored to be among the global first 10 listed, recognized by Side Effects to be a Houdini certified instructor. I have been using Houdini for a very, very long time. So more than 25 years, in fact. So this is a Side Effects CEO, Kim Davison. So honored that he visited our studio that day. And in our hands, we are holding a CG artifact, a Houdini artifact. This is a Houdini 2.5 manual. Today is 21. Those days when we learned Houdini is just flipping manual. This was before YouTube was born, before a single video DVD has been shipped out of US or any part of the world. We learned Houdini by flipping manuals. And I kind of have so honored to kind of help many communities. For instance, I collaborated with Side Effects APAC to Brunei Economic Development Board to help their people with media, visual effects, and entertainment and things like that. So I'm very honored to kind of speak at this Asia conference stages. For instance, in SIGGRAPH Asia, I'm speaking alongside with giants like DreamWorks. I kind of vaguely remember that the speaker told me, "Oh, Doug, we have 300 people in our studio." So I'm so honored that I only have 3. I'm standing beside him talking about our small production from Singapore. So, and that's where I kind of get connected to other users of Houdini. Another SIGGRAPH Asia was speaking alongside Electronic Arts Sports. They are talking about how they populated stadiums in their games, in EA games, using Houdini to kind of crunch the data. And talking about movies, I was very honored in SIGGRAPH Asia Hong Kong to speak alongside Digital Domain. They are talking about Iron Man 3. I'm talking about my small production again. So, but today, I don't want to talk about my old production so much that I presented those days. I want to bring you to the path of, hey, how can I apply Houdini in other aspects? So during the pandemic, I'm very honored to be invited to the CG community in China to talk about Houdini, talk about Unreal Engine. So it's really huge response, really wonderful. You know, one webinar can be 1,300 people, and their Q&A can be 1 hour. You know what's the most common question? Hey Doug, how do you connect Houdini's data to Unreal? How do you kind of get this data out for real-time application. So today I'll talk a lot about that. So this is a commercial course that I did in China. These renders are in UE4, Unreal Engine 4, not even Unreal Engine 5. So you can see, so I begin to see, okay, I was teaching people, and all these intricate Houdini digital assets generated procedurally can be realized in real time. So today I would define myself as a regional speaker and trainer. I'm going from country to country in conferences, kind of like in education summits. I'm training top studios, kind of like top institutions and things like that. So today, I'm going to talk about something like crossing boundaries. Crossing boundaries is a bit weird, because crossing boundaries means you're crossing over to an area that, yeah, I don't belong here. So I'm here, but I would like to go there because I think I'm useful. So but before we can talk about crossing boundaries, I think it's important maybe we cross some borders, go to a few countries and check it out. So tonight there will be a little bit of a travel around with me. So we'll go to Philippines, look at architecture. We will kind of go to South Korea, look at metaverse development. We will visit Hong Kong to look at cross-disciplinary education. We will kind of go to an international conference and check out how AI-driven pipeline can be done in Houdini. We will also look at cross-cultural conference, that is China for their APAC Mandarin-speaking audience. And we also talk about virtual production. ICVFX is like what Nanyang Poly is doing in Thailand. And let's start with Philippines, okay? Let's talk about architecture. By the United Architects of Philippines, they have this national convention. It's the largest ever. So very honored that there's 2,000 over people that attended my session. What I'm talked about is, okay, so it's very well covered in the papers as well, how game engines are transforming architecture. You will see where Houdini plays a part later. So in Manila, in Philippines, there's this national icon called Manila Central Post Office. It's a century-old building, and it's went through war many times of restoration and rebuilding. It's their national icon, it's their pride. 2 years plus ago, it was devastated by a big fire. It's a really sad part of Philippines history. I have an idea. I'm speaking at a national conference. I wanted to honor their culture and their architectural profession. What I did was, this is the current state of the building. It's a very badly burnt. So, okay, the difficulty is century-old building, no floor plan, no architectural information. I wanted to recreate this with Houdini and rendered in real time in Unreal. So this is the structure that I recreated for the event. Very well received. This is the viewport in Unreal. Okay, this is the exciting part we're interested about. So this is made in Houdini without a floor plan. I just had photos from the past, from the burn condition. Difficulty, massive structure. It must look correct from afar. I'm presenting to architects. I was very worried if they will pick on it. They didn't a little bit. So the other challenge, highly decorative motifs. Intense amount of data. Just, you check out the network, it's no small beast. What I did was, I worked with two of my mentees to kind of, for instance, you see the pillar, there's this Doric motif that was made in Blender. The rest 100% Houdini. This beautiful door motif is made by my mentee, Cherry over there. So wonderful to work with her. This is done in Blender by another mentee. Both are MIP alumni, by the way. So, okay, let's see. Why Houdini? Okay, the idea is I wanted to talk about refurbishing, right? Restoration. Maybe some motifs need to be recreated. So I want to do an architectural proposal. Why don't try different motifs? Maybe what's the spacing in between them? And all this can be part of a discussion with the restoration committee, with the architects. That means we can predict what will happen procedurally. So this is what is rendered in Unreal. So one of the vision of the architects is they wanted to kind of like restore this as like a grand hotel. Some architect told me you have Fullerton, right? Yeah, we wanted something like that. So in order to achieve this, it's kind of difficult, you know why? Because I was doing the exterior. I have to go into the hallway and everything must make sense. You see the flute there? So the flute, if you see from far, is okay, but you go so close, it's going to be pretty difficult. So what I did was, when I kind of connected to Unreal Engine's Lumen, real-time global illumination system. So what happened is, right, the whole process, I manage it by breaking up different parts. For instance, the pillar is actually another set of data. Because it's procedural, I can kind of control the gap in between. I can update the flute, what's the depth of it. I actually went to see the photo to calculate how many flutes. So if I miss one, I can update it procedurally, and I can port it to Unreal just back and forth. So it's a very intuitive process, especially working with a real-time engine. So the next thing is, right, we are entertainment people. We write ambience, we write feel, we write grandeur and things like that. Okay, I wanted this volumetric light effect. So the thing is, you see the ray for volumetric light, those of you who have done it, you know, right? The light need to hit an object, the light need to be obstructed, you need to split up, then you get the effect. That quadrant on the top right hand corner that you see there was done at a separate element. So what I did was, I kind of looked at that camera angle, how the light split. If it doesn't split nicely, I'll go back to Houdini, update the gap, the kind of the structure, I load it back again, and kind of go back and forth to achieve the vision that I want, to create the impressive, grand kind of a structural feel. The other thing is, right, we need to get our data, the model real-time ready. So for Unreal, we're working with Nanite, this virtualized geometry. Okay, you see all these net boxes here. Every one of them will represent one category of structure. For instance, some will be the motif, some will be the pillar, some will be certain part of structure. Every one of them have an individual output directly connected to Unreal Engine. So the thing is, okay, what is the advantage? The advantage is because when you want to compute or convert a typical model into a nanite ready mesh, it's like you need to, if you load in the whole thing, like what you work in other packages, this is a very dense data. It's going to be very slow. But because I can work procedurally, I can update it on the fly. Not only that, I think that's happened more than once. I was doing the exterior, looks good, right? When I did the hallway for the Grand Hotel, hey, the hallway is too narrow. I have to pull the back wall backwards a bit, and I need everything to adapt, including the metal grid, including the decorative thing. So once I do that, I just refresh, and it will continue to compute and update. So let's talk a little bit about programming. We are not programmers, we are not comfortable with it. But I think in the future, as artists, as technical people, we need to kind of like work with programmers. So for instance, this is a door. Because it's procedurally made, it's very easy to create an interactive piece that if a person go close to the door, hit a shortcut key and the door will open. This is Unreal Engine's blueprint. What you call that? Is a visual kind of programming that even you can pick up on your own. So the thing is, we want to talk about crossing boundaries. Let's push it further. In this Unreal Engine, actually there's an easier version. There's this thing called a twin motion. It's actually very easy for product designers, interior designers. A lot of people like to do that, you know why? It's very easy to use. Okay, I'm not here to talk about twin motion. I want to talk about our next generation, future kind of presentation. Twin motion cloud. Okay, this is twin motion, very easy. As you can see, I can populate the place very easy. I can block out a few cameras and all that. All the structures, again, is created in Houdini. And what I'm doing here is, I'm firing out this data to the cloud. So what's the advantage? This is no longer your laptop. This is Microsoft Edge. This is presenting on the cloud. What does it mean? Your client can view it on the iPad. You don't need an NVIDIA high-end card to push this back. He can interact with it and so forth. But the key is, normally game engines are not fantastic at asset. And even you can build asset, you cannot proceduralize it at Houdini. So I prove a point at the architecture conference, you guys should go procedural. So let's go further. You know, the thing is, yeah, entertainment and game and all that. You know, Epic Games has this famous Fortnite game. I think some of you might be playing it. Okay, what is cool about, I'm not going to talk about the game so much. I'm going to talk about the platform. So the cool thing is, there's a version of Unreal that this Epic Games made. Is called Unreal for Fortnite. So this is the Unreal Engine for Fortnite. And I loaded in the same asset, and I'm firing up to Fortnite platform. It's multiplayer. So what does it mean? When you can create, even for entertainment, your asset, you can load it up into the virtual world and there will be a lot of audience. How big? 600 over million registered users, 100 over million visitors per month. So you talk about if you want someone to watch your movie, perhaps let someone visit your beautiful world that you created. You have made one for the movie, try one for the real time, but I encourage all of you go procedural so that your movie version might be more dense in detail, and where you can go for the switch over to a real-time version in Houdini. So, okay, in the future, what we might be collaborating is maybe we might be doing architectural visualization, cinematics. So our skill set, we might just kind of think out the box, crossing boundaries. We might be working on a timeline that is not for filmmaking or TV commercial. We could be working with people like engineers, structural designers, architects. So the thing is, all our skills and discipline will still apply, because I believe we can make our renders look better than the people from the other technical disciplines. So real-time rendering, do try it out. I think it's also part of things that we cannot avoid. It's just like AI, we need to investigate. Real-time rendering, I would want to encourage you. Okay, so much for Philippines. Let's go over to South Korea. It's a 100X conference. It's a conference that they invited experts from AI, Web3, and real-time to be at the same conference. It's held at Korea University, one of the Korea's top university. It's also government funded. There's a reason why this thing happened. So what happened is, right, this is the governor of Gyeongbuk-do. This is the district that in South Korea that we are doing the event. So he gave me a very interesting gift. He gave me a Korean wine bottle with our faces printed on it. Pretty cool, right? But what is more cool is his vision was printed on the bottle as well. He said, Gyeongbuk, the capital of metaverse. So I think in recent years there's a huge stir about metaverse. So what the organizers think is, you need to create the future metaverse. You need AI, Web3, and real time. So our skill set definitely can contribute to metaverse. As I've shown you, it's very, very efficient if you do it in Houdini by procedural means. The topic of my presentation, how the power of proceduralism accelerate real-time creation. Real-time can render fast, but it cannot generate assets worlds fast. You need Houdini's kind of proceduralism. Example, okay, I told you I'm 25 years old, right? I have some old things to show you. This is a 10-year-old demo, okay? Back in the day, I am making little films, and this is the pillar that I made. And the thing is, the pillar, I can control the radius, and the flutes will adapt. I can change the number of flutes. I can have all these very intricate details that will automatically snap to it, and you can create all sorts of details on it. So what does it mean? If you invest your time to create a digital asset that has the kind of capability, this is 15 minutes. It's not days and weeks. This is another 15 minutes. You know, we are all visual people dream of visions that no one has seen before. Yeah, I made one that no one has seen before, 15 minutes. You can't find it in Tilbrook, it's mine. So the thing is, how does the whole pipe work? What I did was, I have a studio back in the day, only a few people, but we have interns. I asked them to trace some motif. This motif will be able to load into asset. And you know what? I didn't create these pillars. I hand over my tag, my asset to my interns, and they load in some motif, and they came out with something that I didn't think it can be done. So the moral of the story is, if you, people say Houdini, you spend so much time making the notes. Yes, but if you do it well, you can hand over to your colleague, and they can come out with something you can't even imagine, because you are extending your knowledge, and you put it in the hands of people that can extend it further. Okay, let's take it further. You know, I like fantasy towers and things like that. I'm a Lord of the Rings fan. So I wanted a model assembly that I can put in the pillars that I made, the motifs that is done. I want something that I can control different stories of pillar, different radius, but I want to control the details at the same time. And again, this is 10 years old. Okay, if you are as old as I am, not many, you might have heard of this thing called OTL. Today, if you do digital asset, the extension is .hda. I see some people in the crowd smiling. Operator type library. This is operator type library. I went to a movie with my team. I saw this spiral staircase in the World of Warcraft movie. I went back to my studio, I added it to my asset, updated it, I said, hey guys, the movie that we watched that day, you told me you like the spiral staircase, you have it in your asset now. This is how fun going procedural is. Okay, this is about the network, the 10-year-old network that need to communicate in all the data across the layout. And what you can do is you can generate a lot of different variety of towers. And okay, let's say talk about pipeline, because I think there's some TDs here. What you can do is you construct a pipeline that has motifs, load into pillar. The pillar can take advantage of the motif and become a decorative pillar. I also make a tag that can make a 2D motif into a 3D model. You can all assemble into a tower, and thus 10 years later, I'm going to Korea. I know they do fantasy games. So I wanted to do this fantasy production so that we can connect. So I took my 10-year-old OTL, not HDA, OTL. I invested a lot of time in the old version. I added in some nodes, I make it real-time ready. UVs are ready, geometries are ready, and this is the 2023 version of my tower. This is in Unreal Engine, real-time ready. 10-year-old investment, reaped a few years back, and I loaded in some Megascan texture. Okay, I loaded in a combination of towers and buildings, towers and models, not many, I think like 36. And they did terrain. So I created this terrain in Houdini. I run through hydro and thermal erosion. But if you see the Houdini 21 demo is cooler. I wish I had that, but no choice. I baked out a few data map, water, sediment, debris, or data map. You know why? Unreal can read them, that's why. And with the height map, of course. So this is in Unreal with the Houdini generated terrain with height map and data. I also created a auto material on top of that. It can work with the data map from Houdini, and at the same time, there's also the auto kind of noise and detail. That means auto means closer to the viewer. It will give you a certain resolution. Further away, it will do that. And because I'm a Houdini guy, I can pick up other technical things very easily. Okay, let's talk about proceduralism in real time. Okay, so this is a PCG volume. It's Unreal Engine's procedural technology. So very common, similar to Houdini's technology. Within this volume, I can do randomization, placements of buildings and all that. But there's a difference. This can be triggered in runtime. I can switch different layout in runtime. So because of my Houdini skills, I see another procedural program made of nodes. Yeah, I made another pipeline. It ain't so bad because I've been looking at nodes all my life. So what I did was, per class of building, let's say I made around 30 over buildings per class, per type. And okay, I spawned not many, 18,000 trees. And what I did was, I used the Houdini move again. I use a curve, plot the area I want. So all these were randomized inside. I plot a road. Any road, there's any path within this path, no trees and no buildings shall be spawned within this area. And in 10 minutes, I rendered this. Okay, so the cool thing is, when you extend your skill set out to cross over the boundary to other industries, you will open up a new world of possibility. I've never rendered something so fast before in 10 minutes. I try another angle, another 10 minutes. Okay, what is cool about the creative process? When I was rendering at this angle, this is not the final one, I see that, hey, I need a 3-story tower. I go back to Houdini, just quickly 3-story tower, load it back in. In Unreal, I just pull the data back. Because the whole tower asset has been made UV ready, real-time ready. I don't have to fix that problem again. Those set of nodes permanently makes you able to send the data out to real-time. Fun, right? 10 more minutes and another shot. So in future, I will guess not only we think of creating the thing entirely in the package we are comfortable with, in my case it's Houdini. In the future, I believe we will be working with metaverse development, all sorts of things, and using Houdini as part of the pipeline. This pipeline, this part, Houdini, this part, Unreal, all working together. So we must cross boundary so that we can extend our skills and work in more markets. So a pipeline, never use a pipeline once because it's very difficult to build. I dream bigger. I want a bigger terrain. Same drill. Once I make the first one, the rest is lightning fast. Okay? Let's generate some maps, a bigger terrain in Unreal. This is the world, much bigger, more complex now. How complex? I have 30 over building per class just now. Now it's 2,000 over building per class. And I just make the line bigger, that's all. Draw the road where I want the area to be. And 10 minutes later, 100,000 trees, thousands of building, or a combination of Houdini and Unreal pipeline, the terrain as well, Houdini is responsible. So it's kind of fun, right? Let's do another one. You know, Singapore, we don't have much mountains, so I start to dream. I want a city on top of a mountain. Who cares? I'm in Korea. Nobody knows where I'm from. Where I came from, there's not much mountain, so I just entertain them with the future metaverse. You combine Houdini and Unreal, you can you can tell your Korean fantasy movie and your Korean metaverse combining this Houdini and Unreal pipeline. Okay, let's go over doing in Hong Kong. I was very honored to be invited by the Hong Kong University. Hong Kong University is very prestigious. It's QS World number 17, Hong Kong number 1. So what I was doing there, I am actually training multi-faculty, multidisciplinary staff and students. So it was very well received. Okay, so the cool thing is I have lecturers and students attending from architecture, IT, engineering. Well, you cannot imagine. I even have linguistic. I even have dentistry people coming into my workshop. So what they want to do, they want to learn Houdini, they want to learn Unreal. So now you know how valuable my 25 years over investment is. Now I'm reaping. Now people from all walks are listening and learning from me. Okay, in Hong Kong, right, before I was there very early, before year 2000, before 97, I was there. There was a look in Hong Kong back in the day, we call it neon lights. Very beautiful, and now if you visit Hong Kong, not many left because mostly torn down. So what I did was, I wanted to create a interdisciplinary cross-culture training material for them. This is a procedurally generated building in Houdini, and they are learning PCG in Unreal. You use Houdini model. The models, the neon lights are made in Houdini. You won't believe it. You thought it's some package they normally use. He is a programmer. This is a programming lecturer. This is an architecture lecturer. I'm talking I'm the architectural lecturer using my Houdini generated building to explore how PCG work and real-time spawning. I think he's a character-driven researcher. This is a very happy professor, and the dean is super happy. You look at them, they're happy with the workshop. Houdini and Unreal combined. Okay, let's see how it is. This Houdini model, neon light, loaded into Unreal, fire up emission data, and voila. In fact, the PBR material, if you use Houdini and use Unreal, is very similar. So you can, in fact, there's a Houdini material attribute that can be read by Unreal. You can check it out if you're working on real time. So the building I showed you has created all this silhouette, not made one by one, made by one primary digital asset. If you want to know about digital asset, join the NYP course, they will teach you digital asset. So this is a building. I can just trigger balcony. I store presets as well. I don't have Houdini 21, I made my own presets. So there could be a commercial building, could be a condo, could be anything. And the thing is, I upgrade one part, I made it real-time ready. This is a 3-year-old, 4-year-old demo, but the version you saw in HKU has been upgraded. So again, I invest a lot of time making something very powerful. I can upgrade it to be real-time ready or whatever ready, You can work with whatever platform you want. So it created all this silhouette. Okay, this is cool. Those buildings, they are learning, the architects are learning from the engineers, Houdini models. Neon lights, Houdini models. That's many years ago. I upgraded to be real-time ready. They are learning PCG using buildings in Houdini. I want to bring your attention to this. These few houses, right, my goal is I want to teach them how to make a shop house with as little nodes as possible. It's a very simple asset. Have a little mental note of that. Something will happen later. So all this, I want them to immerse in learning in a culture that they love or once forgotten, or even the youngsters, maybe they haven't seen a real rich neon light scene. So I combine Houdini's proceduralism. All the models that you see, the structure, everything is Houdini, including the scaffolding. And I can turn it day to night, and suddenly a kid that has never walked a street full of old neon light, they can tell the old Hong Kong story. So this is my, many a 10 over year or set, I make it real time ready. Let's come back to Philippines for a while. There's a reason why. At the architectural conference, right, huge discussion. I think all of you will experience it. Hey, AI, how does it affect us? How does it affect architecture? How it affect your line? Okay, cool. I kept that in mind. After the architectural conference, next day, I was invited to do a keynote at Our Lady of Fatima. That's my client. I did a keynote, and I showed off just now that old century-old post office there, right? And the director that invited me said, hey, Doug, how cool if I have a virtual version of our building. It's called the Rice Tower. The Rice Tower is very meaningful because they have 6 campuses. Rice Tower is the symbol of, because the research center is there, and there are a lot of their academic excellence is represented and all facilitated in the Rice Tower. I want a virtual version. It's a dream, Doug. I don't like people to tell me about dreams. It becomes my dream too. So this Rice Tower, I came back to Singapore. What I did was, I don't want to do the same Manila post office technique. AI, okay, let's see what it can do. I created the AI-driven pipeline for an international conference, later on organized by them. So this is Sparks International Conference. So I'm so honored to be speaking alongside experts from US, Canada, New Zealand, London. So quite a number. So the cool thing is, right, if you represent your country to speak, your flags will be there. So I'm glad that our flag flew in the international conference. Super happy about that. Okay, I talked about creating the metaverse, developing virtual versions of the actual world. So generative AI, we all talk about it, it's hot today. Okay, you know, in architecture conference, they talk about, hey, how it help architecture, you can put your sketch in, it will propose various kinds of look. So it's very good at painting a beautiful picture, we all know that by now. But I want to make a pipeline. You know, I'm so pipeline crazy, I don't know why. I want an AI, procedural, and real-time pipeline. So let's look at generative AI first. I load in a photo of the Rice Tower into Stable Diffusion. I don't want an alternative version. I do not want pretty picture. I want what AI was originally trained with, segmented data. You know why? Segmented data, they know what is the difference between a door and a window. They want to know what is the difference between a dog and a cat. So segmented data, not bad. I can use that. So I didn't tell the university, it was a surprise. So I told them, I went back to Singapore. I Google Map, I looked for Google Map to get dimensions and the floor and the top view, various photos. No floor plan was given to me. I didn't ask for it. Okay? So I kind of cut out strategic parts of the Rice Tower for some research. This is the facade of the Rice Tower. I extracted the segmented data. Okay, segmented data, cool. What does it look like? It looks like the facade. It represents the facade, but the rendering is horrible. It's fine, I just want the data. So, pipeline hungry me created another pipeline. AI proceduralism. How does it work? This is the facade. You see I'm loading in various kinds of segmented data, and I made procedural windows to mimic that of the Rice Tower, and I can kind of come out with various kinds of combinations of layouts of the facade from AI segmented data. This is not a normal model. This is a segmented data, and it modeled this sliding full height window that you can slide the curtain up and down. Okay, but because it's procedural, I can manually control how high the curtain can go, how low. But you know what? I'm getting a bit lazy. I don't want to manually slide open and close every time. I wanted automation. So I used Houdini's very unique technology. It's called PDG, Procedural Dependency Graph. What it can do is, I can automate stuff. I can load in, I can give it a bunch of value and wedge it out into 20 versions of different way the curtain can open and close. So what I did was, out of 20, I choose the 10 best one because not only models I kind of exported, automated. That means, okay, what does it mean? I press the button, I go for lunch, I come back, I get my 20 model. I didn't intervene. but I want the 10 best looking waist curtain open, and I loaded it into my procedural system and let it kind of run through the proposal. It's quite fun because, as you can see, I can have a lot of different combinations that is presented before my eye. Quite a fun and creative process. Okay, I also want some manual control. The sliding window, I actually created manual control, so I can art direct it, I can automate it, I can randomize it, I can do whatever I want with it. So this pipeline created the Rise Tower, and this is in Unreal Engine. So the cool thing is, this version of visualization is not the normal architecture visualization. You know why? It looks more lift-in. Typical architecture visualization, you don't have this kind of lift-in windows open door and close, that kind of thing. So it's kind of unique to what I have developed. In fact, we are collaborating to work on it further with some funding. So this pipeline, don't use it once, use it more. In fact, I gave a sneak peek of this presentation when I was in Hong Kong University. The first day I was in Hong Kong University, it caught my eye, this beautiful commercial structure. So I don't know why I go for a tour, I don't take sunsets, I take buildings, it's always me. This is the model you saw just now. I remember I have a talk at 11 something. I think 8 a.m. in the morning, within a few short hours, I implemented Hong Kong commercial building into the facade. So it goes further. I was doing a workshop. I was having lunch, I crossed the hallway. I saw this beautiful facade. Hey, very beautiful. So I kind of like my inquisitive self, I studied actually it's held together by this thing called a fixed point glass system, or the spider glass. It represents the X shape that clamp the glass together. So what did I do? Well, you guessed it right. I implemented it in Houdini. This is my entirely flexible asset of a fixed point glass system, entirely flexible, that you can propose different kind of structure and a variety. Yeah, so I have some of my mentees are architects and all that. We are working together to kind of like take some of this concept into something more, more beautiful. So yeah, you can. What does it mean? Your procedural capability doesn't tie you to media and entertainment. You can go very far. For instance, structural engineering. So yeah, you can kind of do all sorts of topics, going procedural. You can perhaps help to recreate a century-old national icon, do a proposal for a grand hotel, and maybe, this shot, right, we actually talked about using it as a LED wall backdrop. I think that would be cool. So you can kind of maybe show off some beautiful relic, historic. You can do a virtual museum using your procedural skills because it's entirely flexible. You can create any mood you want in a grand movie. You can kind of create fantasy worlds for the future metaverse for your games, really swiftly and procedurally. You can do your AI research or whatever research combined with proceduralism. You can actually do a cross-cultural teaching. For instance, in the Hong Kong University, I did that. But the thing is, even in Thailand, I was there like few weeks ago. It was a national initiative where, for virtual production, you see the LED wall there? Yeah, so we are currently in discussion of using procedural asset to drive the LED wall. Again, attended by game artists, AI people, directors, producers. Going procedural, in fact, I show them Houdini demo. They love it. They want to use it for more aspects. So can you. So, okay. I want to kind of briefly talk about cross-culture. I was, on Saturday, I was in Shanghai. I was invited by Epic Games to speak at their Unreal Festival. Really honored to be among some of the elite universities. I'm talking about how Unreal Engine can empower education. I'm talking about custom content, cross-cultural presentation and things like that. Very well received. You know, in Shanghai, right, there's this very beautiful place called Old Shanghai Street. It has architecture from 1644 to 1911. Beautiful, really beautiful. That's my problem. I love beautiful things. I made my own version of Old Shanghai Street for the event. I want you to take note to one thing. Remember the very basic minimum number of nodes to create a storehouse. That asset I expanded further to the old Shanghai street. I power it up to become the old Shanghai street asset. And I spam a whole street full of old Shanghai street style building. Very well received. So this is a PCG tag called PCG Grammar that you can actually distribute. And the buildings won't intersect each other. It will just randomize and increase. So again, work with real-time technology. Your procedural skills definitely have an advantage. So this is the buildings in the background was the tall buildings I used in Hong Kong. It's the same file. It's the same project. What I did was I added in old Shanghai. Not only for kind of your work, even your kind of conference presentation, any kind of presentation, you can use procedural skills. So today I've talked a lot about crossing boundaries. We crossed over to architecture, went to Philippines. We crossed over to metaverse development in South Korea. We went for cross-disciplinary education in Hong Kong. We went to international conference, talk about AI-driven pipeline. We went to Thailand, talk about virtual production. ICVFX, we went to Shanghai to talk about cross-cultural conference content. And I want to encourage you to go procedural, use your procedural advantage, go beyond your limits, don't just think of media and entertainment. I want to wish you the very best across industries, across discipline, across Asia. Thank you so much.
Welcome to another SID Hug, everyone. And thank you, Finn, for opening your doors to us once again, this time in your new space. What a great place it is to be. We've got two speakers this evening. First up, we have Josh Tilbrook. Josh, this is your third time in a row of sharing his Houdini wisdom with us. Thank you for that. This evening, Josh is going to be sharing some tips and tricks on how to keep things lean and mean while working in Houdini. So please put your hands together. Give a warm welcome to Josh.
What are you doing? Spoilers. Sorry. Thanks, man. Hi. Good evening, everyone. My name is Joshua Tilbrook. I am a effects lead here at Finn. Tonight, I'll be talking to you about keeping Houdini lean and mean. We'll be going over strategies and keeping your scenes efficient, both conceptually and technically. Before we get started, here's a short reel of some of the effects work that I have been lucky enough to participate and work on here at Finn Design. Cool. Thank you. Houdini is hard. It is an extremely complex tool that produces amazing VFX. But because of this, it's quite often overwhelming for anyone looking to start. So tonight, this presentation is about helping those artists who are looking to start Houdini or any current Houdini artists that want to speed up and declutter their workflows. Overall, tonight's goal is to feel a little less overwhelmed by Houdini by supplying guidelines and structure to your scenes. Let's start with a bit of conceptual. Scene structure and layout. When starting a task, the first thing to think about is how to divide it into manageable chunks. So for example, let's imagine we have a client, and this client has given us a task. We have a motorbike, and it needs to tumble down a hill, falling apart as it goes down. You were given 3 assets: the bike, an environment, and a camera. Beginning with scene structure, depending where you are, different levels of this may be predetermined for you. Or maybe you're working on your own and need to build something from scratch. Having a simple and repeatable scene will greatly speed up your tasks and simplify your setups. This here is an example of the effects template at Fin. We have the first blue area, which is for general pipeline HDAs and asset ingestion. Purple, which is for out-of-pipeline imports. This is very rarely used and very much not recommended, but sometimes you still have to do funny things. The green area is working on SOP and DOP setups. Yellow is for lights. Gray is for previewing. Light yellow is for LOP networks, and red is for ROPs. We also have a template of how we expected effects artists to work inside the Solaris graphs. This can be a bit more rigid in structure, but apart from that, this is it. It's relatively loose and up to the artist to decide how they want to work and what's best for them. So getting started, we'll start by bringing the bike asset our client has supplied. The first blue area, which has 2 purposes, pipeline tools and ingestion. We can see the bike is being loaded in with nothing else. Looking at the bike, we can already see this will be tricky to simulate as it's full of planar faces and small pieces. But we won't do collision and simulation prep in this section. This is just for bringing in the asset. Similarly here, we've been given a terrain. Our client is expecting us to tumble that bike down this terrain. Again, the terrain is not collision friendly and it needs some work. So now we have our assets, we need to think about the next step. What do we need to get these assets ready for an RBD sim? We need to build collision geometry for the terrain and prepare the bike as a hero RBD asset. Moving to our green area, this is where we do most of our effects work. You can see here it's split up into 3 different sections. One for just setting up collisions, another for preparing the bike for the RBD, another one for the actual simulation. The first one is pretty simple. Get the environment, generate a height field using the project SOP based on the size of that geometry using bbox and Centroid H scripts. The second one is a bit more fun. As we saw before, the bike is full of planar faces and geometry that isn't great for simulations. The following topic is a big point I often see neglected. Trying to get your assets quickly through into a sim and glossing over your asset prep time. In an example like this, having an asset with unoptimized collision geometry will do 2 big things. Introduce instability and potentially reduce the speed of your simulations. Spend the time before you get to simulation on your prep, and you'll make the time plus way more back. In terms of collision prep, this brings us to one of my absolute favorite nodes, the convex decomposition SOP. This thing is just magic. You give it a geometry, preferably mesh that isn't planar, and it'll generate you convex holes, segments determined on your design concavity. This geometry is exactly what RBD sims look for. It's almost like 2 button presses to get it working, and it gives you really good geometry just straight out of the gate. Even if you need to create watertight meshes from stuff that isn't great, always use this thing, then you can get the right concavity you want and then turn that into an SDF collision stuff for later. And it's an easy, good way to build yourself this watertight meshes. Getting a bit more complicated, this is another technique I use all the time. Getting a bit more complicated, it's another technique I often use to help combine small pieces and planar surfaces into watertight meshes. Everyone who's been in this position has probably tried the following steps. Fuse, remesh, convert to BDB, back to polys, polydoctor, so on and so on and so on and so on. When you get dealing with this planar meshes and these kind of assets, this kind of thing never works. You end up doing it and doing it, then you get to the point where you start doing manual patches, trying to generate a stable mesh. And from this image, you can see this asset follows from pretty much the exact same problems. Lots of small pieces, 2D things, all that stuff. And either I can spend a lot of time trying to manually wrangle them all into a single nice mesh, or just throw it in a solver. The input starts with a sphere, the size of the bounding box to the incoming asset. Then in a solver, you shrink wrap that sphere onto the incoming geometry, mix in some VDBs from and to polys, repeat over X amount of frames you want to do, and you got yourself a shrink wrap solver. Now, obviously, this collision geometry is really quite crude and basic. But depending on the task and what you need to achieve, this might be enough. And if it isn't, this might need more complexity-tight collisions. Splitting this geometry out into more individual sub-pieces and running more convex decompositions and watertight shrink wraps will get you there. And this process is repeatable. You can use it for almost everything, and it will always result in usable geometry for your simulations. But for now, this is all we need. Very basic, chill, watertight mesh. So now that we have spent the time making the collision geometry and stable RBD asset, we can simulate it. A super simple setup with the names on the same rendered geometry and proxy. We can simulate it and instantly reskim and visualize what we're going to simulate. And this is, very basic kind of setup, but collisions all work perfectly. This took about 10 minutes to get going, and the following steps would be to obviously build on top of this. So the real power behind this isn't how clearly the SOPs are laid out and named. Well, the naming of SOPs is important. It's how clearly defined the areas you're working in are. If you need to go back to adjust on the asset, you go back to the asset blue area and you do what you need to do. You need to work on the collisions, you go there. You need to work on the RBD prep, you go to that area. And it all flows seamlessly into the actual simulation in very clear defined stages. Or maybe someone else needs to pick up your scenes. They wouldn't be searching through your network trying to make sense of what you have done previously. They'll pick it up, see everything's clearly labeled in their own work, in their own labels, and hit the ground running. This example scene, of course, is an extremely basic one. We're taking these ideas and continuing to build it up, adding a constraint network now, maybe in a separate container, maybe adding a pyrosim with debris, their own one. But you see what this does, it turns a rather complex task, looking at it as a whole, into really manageable chunks. The trick is to compartmentalize the work you're doing and focus on each part at a time, instead of thinking about it all as one giant piece. This will allow you to focus more on the creative rather than trying to keep track of your scene, trying to manage everything all at once. Break it down into what you can do one at a time. Getting a little bit more toolsy stuff, scene controllers. This is a pretty common technique, and depending on what you're working, we'll probably have different flavors of this idea. The underlying idea is really nice and simple. A global node where you can set a range of parameters and have them all linked to nodes throughout your scene. A global hub for your scene. This will help you keep your scenes cleaner and much more organized. In this example, I'm using a scene controller to determine the resolution of the flip sim and the speed the swell is pushing the little flippy around. At Fin, we do our work in a multi-shot context. This means that we have one global working file per effects task, and then we use Houdini's context system to set important parameters in the scene and cycle through shots. The way we do this predominantly is with the use of context switches. Depending on the shot or context we are in, the switches search for the matching input of the same name and we'll use that stream instead. Well, this presents us a problem. If you have different shots, we probably need a scene controller to return different outputs throughout each shot, depending what you need. So my solution is to create the context channel resolver. Instead of having one scene controller, we use 3. The first one is the context channel. From here, we can set parameters and their values. Under hood, this just creates a detail attribute with specified names and values. The second node is the context channel edit. Again, in short, all this does is scan through the incoming detail attributes and allows you to change them very simply with ease. And the third one is the context channel resolver. This node prints detail attributes onto parameters using a Python script. From there, the artist can relative reference copy those parameters throughout the scene, just like any normal scene controller. Then to get this working with the shots, we hook them up to our context switches. And the end result is a few simple nodes that allow you to set global parameters throughout your scene that can be specified per shot. So this is the only thing I'm going to be talking about that's actually not inside Houdini. But it still relates. Have yourself a code library that stores useful code snippets of Vex and Python outside of Houdini. Personally, I use one called Kessler.io because it also syncs with GitHub. Yes, you can use Houdini's presets and recipe system, and I still do, but having a stable library outside of Houdini, you can reference anywhere you are, depending on what you're doing, if your normal machine is available or not. Having this backed up is extremely useful. There will be a time when you need a bit of code and you can't get to it on your presets or recipes. Having it backed up is extremely useful. Actual little bits of workflows. Basically, this is a few little Vex functions that you may or may not know of that I use almost every single day. First one being PrimUV. By sampling the current point against its closest parametric UV position, we can interpolate given attributes. It's just like an attribute transfer. You see this example, I'm using PrimUV to sample the normals of the incoming surface, just like an attribute transfer. And you can see in the example here, I also have an attribute transfer doing that exact same thing. But looking at the attribute transfer, you can see that it returns steps result. And yes, you can fix this by increasing your samples and doing some stuff. But looking at the PrimUV, I've done no tweaks, no changes, nothing. And for free, it interpolates the perfectly smooth result of what this normal would be on that given surface. You can also specify a position on a primitive manually and bind that attribute by that position. It's like in this example, I'm sampling the curve U position to get its color and applying it to this sphere without it actually being anywhere near it. Getting a good understanding of what PrimUV is and how to handle it is definitely really important to improving on your effects. Volume sampling. This one's pretty standard, but really, really useful. It's the easiest way for you to get the value of a given voxel and apply it to a primitive or point, or even another volume. Maybe you need to use the density of volume to influence the color or p-scale of whitewater, or sampling the velocity to push it onto the simulation. You've got to push into your whitewater sims. Or maybe you want to check what velocity values you're getting in a very specific region that's not just a slice or a trail. Using the volume sample is the really easy way just to get this information. And volume gradient. Volumes have normals. We call them gradients. In fact, this is how often we do like whitewater shading in Houdini and other stuff. We use the gradient and we apply that to a PBR reflection on the surface of the volume, and then we get reflections on top of our volumes. And Houdini 21 actually has a new shader just for whitewater. I'm really actually excited to give this a try. So if you need to get the access to the gradient of a volume, just use the volume gradient function. Cool. We're going to have one quick dop trick that I often see a lot of people don't kind of do this. So a common problem that effects artists run into is injecting velocities over again and again and again and again. You're trying to determine where something needs to go, and you keep injecting velocity again and again, and you end up with a uncontrollable sim, right, like this. This is a really simple solution to this. Injecting your velocity into your sim, and then also injecting that velocity attribute into a placeholder. Then in the post sim or in a multi-solve, remove that placeholder attribute from the velocity, and then this will give you non-stacking additions to your velocity. So like you can see in this example on the left, this is just adding the velocities every single frame and it explodes, right? On the second, it adds the velocity on a frame, does a solve, then removes the velocity before moving on to the next frame. This repeating the cycle every single frame, resulting in a nice, stable, controllable simulation. It does exactly what you're expecting it to do. The last bit of advice I'm going to leave you with is the PC open function. PC open is a point cloud lookup function. For example, you can use it to search for nearby attributes on specified points by the amount of distance. This example is using PC open to search for X amount of neighbor points and their position, and then blend them with their current ones. This gives us a cheap and customizable method for surface tension. The cool part about using PC open for something like this is it's customizable. You can do stuff to determine where you'd like more or less surface tension with great ease. So you can see here that I'm basically applying a mask attribute, and then In this example, it's almost the same as the previous one, although I am appending a mask attribute in the multiply, the distance the PC open can search. This allows you to create more interesting shapes and patterns. Basically, it's going like, this is the distance that I'm allowing this particle to search, but it's multiplying it by a mask. And then after that, depending on if the value is 1 or 0, it multiplies that with the distance and allows more to be basically more surface tension-y and or some to be less. You get much nicer shapes and patterns. But if you take this a step further, say you have a pop sim and you want to feel like you want to have surface tension, but you want to design that surface tension. You can sample that. You can sample the velocity length of the incoming particles and adjust how far each particle can search for its neighbor by its speed, allowing you to gather more surface tension only as the particle slows down. I can't lie. This is actually the last little tip. So this here is a ROP tree, and yeah, it's a really quite large one that I've actually been working on for the past month and a half. For context, it is a large-scale ocean simulation with like white water, shot overrides, foam, spectrums, yada, yada, yada. So each one of those nodes that aren't a switch represent a SOP network on their own. And as you can imagine, it's difficult to maintain. But sticking diligently to scene structure has allowed the scene to grow but remain iteratable and fast. One thing you have to remember is as your scene expands and becomes more complex, at the same time it also becomes more rigid. By that I mean it becomes harder to change and address nodes. The best way to avoid falling into this trap follows 2 simple rules. Compartmentalize your setups. Looking back at the start of tonight's talk, we talk about how we went over having different areas for asset import, collision management, sim prep. Break it down into manageable chunks that is easy for you to compartmentalize and maintain. And the second is, do not get attached to your setups. You may have worked really, really hard on a network or scene. You may be really proud of what this setup can do. But maybe suddenly you get a note from a supervisor or client asking you to adjust that setup to do something different. So you have a good try at addressing these notes, and although you find your network doesn't really work well with addressing them, but you really like your setup and you've worked really hard on it, and you don't want to get rid of it. So you try to make it work with what you built. You spend a lot of time, but at the end it's still kind of like, it's not quite right. It's not quite there. And the answer was that what you really need to do was realize that you need to cull it back at a certain point and rebuild part of the network. You need to think about it as your network as an evolving graph. Something that can change and something that's okay to lose a limb because it's going to grow back a better one. A lot of understanding when a good time is to restart part of your setup, it does come with experience. But the message I'm trying to make here is do not be bogged down in trying to make your network do very specific nodes for hours or days. Don't be afraid to trim it back and rebuild it. And when you rebuild it, you will rebuild it better and you will rebuild it quicker. Essentially, all I'm talking about is trying to fit a square peg through a round hole. Just get a cylinder. And that brings us to my end of my presentation tonight. Thank you all and have a really good night tonight. Thank you.
Yeah. Thank you, Joshua. It's fantastic, as always. So who has questions for Joshua? Here we go.
Hello. So in your daily work as a FX artist, do you have encounter any problems that relates to problem solve where you need to do some physics? Like let's say you have a water jug and then you need to turn it in a very sloshy way, but then because it's very sloshy, it's very hard to get the water contained into that jug.
So, you trying to do a water sim in a jug?
Yeah. But then you can put the jug back to the origin, and then you apply a force on the jug to it. So it's like maybe my explanation is very bad. It's so I have a jug, and then I put it into I'm sloshing it all around.
Yep.
But then because when you have a very fast water, when you do a sim, it will.
You mean like volume retention inside like a moving thing? Yeah, that's really quite tricky. There's a few ways that like I've done that in the past. As you kind of were talking about before, a very common way is to move it back to origin and then extrapolating the velocities and forces that the animation does, and then pushing that back on at origin.
Yep.
Another thing I like to do when you do that kind of solution is to do like temporal smoothing on the incoming forces and animation, because if you get like animators don't really think about too much about like, is this moving very quickly, doing odd movements, which affects your sims. So a bit of temporal smoothing before you reapply the forces help, that kind of thing. Another thing too is I've been playing recently with like vellum fluids, and it works quite well with volume retention because effectively it's just a grain simulation, particularly. So that's another good way. Small scale like fluid simulations, Flip's really cool and good for this stuff, but sometimes like a little grain sim actually works really well as well. That like I've done ones where I haven't had to move it back to center of origin because it's a grain simulation. You do enough work and it retains its volume preservation.
Got it. Thank you.
Any more questions for Josh?
Just first off, I really love your presentation, and if it's possible, could you share these presentations in the future? Just to look through your slides, because I love your tips. And secondly, I've got more of a question about learning Houdini in general. I feel like right now I'm at a stage where I'm often watching, masterclasses about whitewater or like vellum and etc. And if you begin with a project, oftentimes you're going on YouTube and you're looking at, okay, is this tutorial right? And a lot of tutorials are using old nodes and such, and workflows that aren't exactly great. Do you have any tips or resources that you could point towards for learning these things?
I mean, I read the Houdini documents still every single day. That is still the go-to for most everything I do. I still do tutorials, I do all this stuff too, but most of the time what I do is I look for tutorials that also share a HIP file, something that I can actually see what they've done and follow along with, like actually in person. And sometimes, sometimes tutorials use older nodes, but then it's just cross-referencing back of what they've been replaced with, and it does take a little bit of work. I don't have really specific like tutorial places to go to, like in Tagma, all that normal good stuff. But the takeaway would be ones that you can find specific HIP files for and follow along with yourself, because they'll either work with the updated nodes and you can easily follow along. That'd be kind of my go-to.
Thank you.
Well, here we go.
So when working in a studio and you make all of the really big projects, is it like a combination of different software? Like, for example, Houdini does the simulations, then you transfer the result into Maya.
It depends on the studio.
Depends on the studio.
We're predominantly a Houdini studio, and like a lot of our back-end stuff in CG happens in Houdini. We still use Maya for animation and modeling, substance behavior texturing and stuff. We use a lot of stuff, but it depends on your role and what you're doing as an artist. Like, I've opened up Maya the past year, maybe like 4 times. So it depends on your role and what you're doing, and the company you're at.
Can I ask what you did for like the creator?
That was the energy beam from the ship coming down.
Yeah.
And I made the environment, and then I did all the lighting and interactive rendering from the environment, just the generic environment, and the interaction from the laser. If that was all still in Houdini.
Okay. Yeah. Yeah. Oh, yeah. That's all.
Anyone else? Here we go.
A great presentation. Absolute novice at Houdini, can barely add fuel to stuff. This is the first time I personally have seen someone compartmentalize the things the way you did. Is that going, and everyone can laugh at me because I'm really basic at Houdini, but is that going to also help in not just simulations, but also creating scenes, lighting and rendering inside Houdini? Or are there different layouts or a different compartmentalization layouts for that?
So I didn't get too much, I didn't talk about our like USD and Solaris stuff because that's, I could talk about that for a very long, very, very long time. But the parts to take away from it are the fundamental conceptual kind of rules. And yes, the same things apply to everything. Like compartmentalize the work you're doing, break it down in manageable chunks. Don't think about I need light and shade, do motion blur, you know, set displacement all in one thing. Just do little bits at a time, and then together it combines into one, you know, big thing that you're doing.
That makes sense. Thanks for that.
One more question for Josh.
I just wanted to ask about that remesh setup you had earlier, because the way I'm looking at it, I'm thinking you're just making a bunch of spheres and deleting them based off of what the exterior is, or am I getting that wrong?
Oh no, so it was basically, you know the shrink wrap salt? Use that thing? Yeah, so it's similar, or it's quite similar to that. It's basically getting a sphere, getting the bounding box of your object you're trying to do, putting a sphere on that so it gets the same size so it encapsulates your whole asset. Then it's just pushing that into a solver and then raying that sphere onto your asset, converting it to VDBs, back to polygons, probably do that one or two more times with a few different tweaks, and then just looping that again and again and again for probably like 25 frames. And that resulted in a watertight mesh with pretty convex attributes, but if you need to break it up, I usually just split up into more and more pieces and then work that way.
Okay.
Thank you. Well, if you have more questions for Josh, grab him over a beer. Thank you so much, Josh. Please put your hands together again. Thank you, Josh.
Thanks, everyone. Thanks so much.
The next speaker this evening is Adam Lee. Adam's a technical consultant at Side Effects. Prior to joining Side Effects, Adam spent 14 years with ILM as an effects soup. This evening, Adam's going to talk about some of the new features in Houdini 21, and he's going to pick out a few of his favorites for us. So please put your hands together, give a warm welcome to Adam.
Hello. All right, hi everyone, I'm Adam. So today I'll do a quick overview on Houdini 21, and then I'll highlight on 3 different features. Right, so I'm a technical consultant at Side Effects Asia Pacific, and we have an office in Singapore. So that's where I'm based from. And these are some of the works I've worked at during my time at ILM Singapore as a FX supervisor and CG soup. So we are really excited that Houdini 21 have launched a couple of weeks back, and the theme is to finish what we have started. So we have introduced a lot of new tools and workflow in 20.5, and in 21, we make them more complete and full-featured. So these are the tools that have moved on from beta to production ready. So firstly is animation with upgrades to ragdoll, constraints, and you are seeing the post and animation library now. Then rigging wise, we have added more rig components, facial setups, and here is the Metahuman plugin that lets you bring in Metahuman from Unreal. Then we have added curve and volume rasterization, a lot of new scattering options, more than 30 new nodes for procedural texture creation in COPS. And some of the tools we have rewritten to make them better. So firstly is the Autis solver for muscle and tissue simulation. Next is a faster and easier solution for terrain erosion. And lastly, 2 separate solutions to deal with texture baking for games and VFX. For new features, we have added auto sleep and surface tension to NPM. A whole bunch of machine learning solutions. So for here, we have this Pyro uprest machine learning setup. And lastly, we have added a sparse Pyro solver in COPS and a lot more. Right, so today I'm going to talk a bit more about these 3 features so you can have a good idea on how to use them. First up is cables in COPS. Yeah, so COPS is introduced in Houdini 20.5. So it is our GPU accelerated 2D context used for texture synthesis, a bit of compositing currently. We are still working on that. And also simulation. So cables are new to Houdini 21, and there's 2 ways they can appear. So on the left, if you look at the green output on top of each node, those are the cable outputs. Right, so for them, they are a combination of all the channels below. And the other way is to set them up manually with the cable nodes, as you see on the right. So here we have 3 different channels. You pack them together into a single cable, and you can think of it similar to pack primitive. After you pack them together, you can filter out certain channels with a cable unpack, or you can bring them back to their original channels. So we can use cables in different scenarios. Firstly, let's see them for creating patterns. So here we have 3 shapes. We pack them to a single cable. From there, we can modify all the channels together, like with a transform or with a color ramp. Right, so there's less duplication of nodes happening. And since this is procedural, you can add in a new shape and the whole thing will still work. We can also do compositing with cables. So for example, you want to add on some distortion. Previously, you have to duplicate the distortion nodes throughout. So now at any point in your COM, you can just pack the channels together, do your distortion, and then unpack them. Right, so you overall just get a cleaner network. Then, yeah, today I'm going to talk a bit more about texture creation with cables. So here we'll see how we create this superhero suit. So firstly, the character is imported into Solaris. And in Solaris, I also have my CopNet where I'm creating my material. So in here, I'm using this preview material node now. The preview material node will let you use your own custom geometry to display the materials. And then any changes in the material settings can be displayed on the viewport. And since we are in Solaris, of course, we can use Karma. So here's Karma XPU with a fast render. So the interesting thing about this is that we are creating a live setup. So on your left is my COP network, where we are creating the different channels, like base color, matterness, spec roughness. And on the right, we have the Karma shaders reading all those maps in. So here we are using the op:: expression to just read in the path directly. That means I'm not writing it out to this, it's just reading any modification straight. Right, so when you are doing interactive work, you can work this way. And when you are ready to publish this character or to finalize it, you can write out the textures, then read from the textures instead. So cables are great for mixing different maps. So here we have created 3 different materials. And then we combine them with blend nodes. All right, so for the first material is the ladder base. And here I'm using a Wooly noise with some distortion. Since this is a procedural noise, it's fully tolerable. And all the maps created get packed together as cables. The star symbol is created with a SDF shape, and I'm using a ramp to create this border. And then here I'm using a height to normal to create the normal maps. Using the new rasterized curve and scatter on curve, I've created these stitches. And again, all the different maps are packed into cables. So here we have a series of blend nodes to combine all these cables. So it's just a blend with 2 cables and a mask. So with cables, it's actually easier to manage this texture network. If not, previously you have to group the diffuse together, spec roughness together, and that gets quite messy. So the result of this is interactive workflow. And this is usually how I lay out my windows. On the bottom left is the Vulkan viewport. So here you can look at your COP network, which means you can see the 2D image or the preview geometry. And of course, the final result is on the top left with Karma XPU rendering with your camera. And since this is a live setup, you can quickly make changes and you can see the modifications as you go. And all this speed you are seeing right now is possible because of the GPU. Although this process is very fast, this video is not sped up, it's running on a 5090 card. Yeah, it's fast, but then it's very resource intensive as well, right? Because right now, Karma XPU, COPS, and the Vulkan viewport, they're all using GPU at the same time. So now, so in Houdini, each of these devices are trying to negotiate with each other. When one needs more resource, the other will free up. So now in Houdini 21, you can manage them with this H-script GPU mem. So it lets you list out how much each device is using, and then you can ask certain devices to free up some memory. All right. Next up is short sculpting for fixing and animating, for fixing shapes and animating shapes. So short sculpt is a combination of the sculpting tools we have in 20.5 and the new non-linear editor in 21. So on the short sculpt node, there are 3 tabs. The first tab is general and it's about all the shapes and the collection of shapes you have. When we create a sculpt, the shapes created are called clips, right? So that's the one you see on top with the slope. That's a sculpt shape. And then the whole thing is called a track. So a track is basically a collection of clips. So clips by default will fade in and out. And then there's options for you to ease in and ease out of those shapes. Right, so you right click, there are a bunch of different options. For tracks, you can use the track weight to animate or to set how the whole track is getting applied, how much is fading in and fading out. Right, so this way we end up having sort of 2 different workflow, and this is all based on user preference. So some users prefer to do it this way, where it's more like a free-form sculpting. So as I going through my timeline, I start to sculpt the shapes. Right, so here I can just quickly do a bouncing ball. All right, and we can go in, adjust the slope, and add in more shapes when needed. Whereas some other artists prefer to have a single clip per track. So that whole track will just have a single clip that you can fade in and fade out. Right, so this will be more useful maybe for something that's repeated. For example, like this guy, when he's walking, his elbow is always intersecting with the bicep. So we can just keep using this shape throughout as he walks. All right, since we are working with an animated object, the deform space is very important as well. So here I'm picking a more extreme spot to see how it deforms over time. And the other thing to take note is that when you are sculpting, the deform space that you are in makes a difference. So right now, the first one is worst space. So for worst space, it usually doesn't carry the shape well over time. Then we switch to tangent space. So tangent space is all based on normals. Right, so when he's moving, you can see that it's carrying over the hip motion quite well. And lastly is joint space. So joint space, you need the animated joints. and your character needs the skin capture info. Right, so with those two information, it can really track the shape very well over time. So other than sculpting, we can use blend shape tracks for blending between two shapes. Here we have a squab with a bend, and there's a version there with a wrinkle deform. Right, so you can see more details on the back. So now in my short sculpt, instead of a sculpting track, I'm using a blend shape track. So with that, I'm selecting the wrinkle deform version. And now when I paint in, the painted areas will blend into the wrinkled version. And the last mode is mask track. So for mask track, let me play. Oh, the video can't be played. Okay, now I'll just describe this. So mask track basically is an animated mask. So you can paint areas where the mask will appear and disappear. Right, so this is useful if you are doing some very precise particle emission. So for example, you have a character walking through the rain and you want like water streaming off different parts. So you can use the mask track to just quickly paint different areas and for that to do your particle emission. Okay. All right. And thirdly will be Shot Builder. So Shot Builder is a simplified USD project pipeline. It is suitable for smaller studios or studios that doesn't have a pipeline support, or if you just want to try out USD. Right. So it supports multi-shot workflow for publishing and rendering, and it also has a simple asset resolver for versioning. All right. So to start off, we have to create a project. So we go to Solaris, Shot Builder, New Project. So here we choose to create a project with sublayers, and this default JSON file will appear. For now, we just save and create the project. Okay, so let's see what we have done. We have created the JSON file in the same directory as the heap file. And the JSON file created have a single unit. So in each unit, there's the associated sublayers. For this generic default setup, the unit here defined is a shot, and a sublayer is a department. So we have like lighting, effects, animation, layout. So to put that into context, if you have your different shots, each of these shots will have these sublayers. And here's a more complex example. Now we have introduced two more units. So the environment unit, it consists of environment likes and environment assets. We have a sequence unit that have sequence-based render settings and maybe some assets override. And we have made some changes to our shot unit as well, as we see on in the white color box. So in the shot unit, we have now embedded the environment unit and the sequence unit. Okay, so the result of that is in your shot, right now you have all your sublayers, and you also have environment, and you also have the sequence override. So you can see how this can be turned into an animation project or VFX project with this way of laying out your structure. To create a shot is very straightforward. So I can create a shot unit called My Shots, starting with 10, ending with 30, with an increment of 10. All right, so after I've created that, I can see all the 3 shots created. Then we go into our shot output node, and we can run it. Okay, so when we are running the shot output node, it is a PDG tops setup, which will go through each shot and do my publishing. Okay, since it's the first time we are running that, if we look at our folder again, now we have a shot folder. inside the shot folder, there is folders for each of the shot. So that's my shot 10, 20, 30. And inside each one of them have the USD files. Right, so this is all automatically set up based on your JSON file. Now let's publish some assets. Okay, so firstly, I go into the edit layer node, and this node is targeting the layout layer. So for here, I use a SOP import to bring in the ground geometry. And okay, so this step right now is no longer valid with the new daily build. You don't need to do this. But what I'm doing here is making sure that my new geometry is in this layer that I'm editing. I'm not creating a new layer. Okay, so you can skip this step. It's all fixed right now. So this is done for layout, and then I go on to do the same for the animation layer. If we look at the box on the lower left, this is saying that we are targeting HPR shot/star/layout. Right, so the /star just means that we are targeting all the 3 shots at the same time. And after that, we can publish the animation and layout layer. Yeah, I'll explain what the HPR means. So the HPR is our own asset resolver. It's called Hyper Asset Resolver. So the USD Asset Resolver is to resolve the relative path to the full path with versioning. So if we check the file directory again, you will notice that in shot 10, animation.usd, this animation.usd is actually not a USD file, it's a file directory. And in it is our actual USD files with version. And since we only make changes to animation and layout, when we publish, only animation has a version 2 and layout has a version 2. Right? So in Solaris, when we are saying that, hey, I'm doing shot 10 animation.usd, the resolver will resolve it to the full path, which is animation_version2.usd. Right? So what this means is that we are actually doing a push pipeline. That means that anytime someone have a latest version, the asset resolver will pick it up and push it out to all the users. So when you take a look at the shot load, the version column will show which USD version we have resolved to. And if you want to, you can still revert back to an older version. And if you want that to go to everyone, that older version can be republished again. And to support multi-shot workflow, we have the shot switch node. So this let us branch out to different shots and make changes to them. So here I'm splitting up into my 3 shots. I have different shot ranges and different cameras for them. And after that is published, you can use the UI on top to switch between shots. So now when I'm switching shots, the camera change and the shot range will change as well. Okay, so now let's look at a typical department workflow. So I can start with a shot load. Oh, this is not playing back as well. Okay. So anyway, I can use a shot load to bring in the latest from all the departments. Then I can use a edit layer node to edit a targeted layer. So if I'm from a lighting department, I can just target the lighting USD, and then I can do my work there. And when I'm done, I can publish that out. And in here, we are setting up the render passes. So in the shot output node, other than publishing a USD, we can also choose to render and publish at the same time. Right? So this is the multi-shot component of it. Yeah, so Shot Builder is currently in beta, and we are looking forward to get more user feedback to improve it. It's not an easy project because every user and every studio have their own preference. So we want to make it generic, but also customizable. So some possible improvement could be adding a UI for the JSON file, so it's easier to set up your structure. And also baking or locking the USD version when you are rendering. Because right now when you send out your renders, in the middle of rendering, if someone publish a new version, because of the push pipeline, the asset resolver will pick up that newer version, right? So your renders might jump. So please give it a try and give us your feedback. Okay, I know I said 3 things, but just one last note. I want to talk about presets, which is something that we have been working on all fronts in Houdini 21. So as you all know, Houdini is rapidly expanding into all disciplines. So there's a lot of new and useful features, but it's also getting more difficult to learn everything about Houdini, especially if it's a new tool or something that you are not familiar with. So the solutions to that is presets, and it comes in many forms. Shelf tools, I know you guys are familiar with. Config and recipes, they are all in the tab menu. So in Houdini 21, you can see presets appearing in all contexts. For Pyro, we have 27 production-ready simulation set up to render with Karma XPU. For Corpse, we have a bunch of dirt map that you can use directly. We also have a library of materials from our content library that you can see how the setup is being done. For rigging, there's a large collection of auto rig components. You can just drag and drop directly onto your character to create your rigs. And our new Otis master setup, it will drop with a bunch of notes to tell you, this is the Otis setup, you can use it as it is, but if you want to customize it to your own character, just look at the instructions on the notes and follow along. And the new Corpse Pyro come with a few config as well to get you up and running faster. Right, so if you are learning a new feature, please try to look for the presets. And since Houdini is node-based, you can just look at the different nodes and figure out how things are getting set up. If you want more intermediate knowledge, look at our content library. There's a lot of setups there with sticky notes to explain how it's done. And we also have our soundeffects.com/learn, which is all the tutorials that we have gathered online. There's a filter function as well for you to search. And lastly, if you want more details, you can look at our help document or contact support@soundeffects.com. Right, there's a lot about Houdini 21 that I can't cover today, but if you are interested, please take a look at the keynote presentation. All right, that's all from me. Thank you. I'll leave the QR code there.
Thank you, Adam. Fantastic walkthrough of Houdini 21. Who has a question for Adam?
Hi, Adam. Thanks for presentation. Just a quick question. My question about COPS, your example with the COPS. Especially interested, should the model has UV for creating this, the example with hero suit?
Yes, yes. You need UVs to create it.
Because sometimes UV have some distortion, and it's a problematic when you try to transfer some texture information on it. So maybe it's need to think about some procedural approach when maybe use some point position or something else, because sometimes models can have some distortion on UV. And in this case, you need to bring back the model and or use some setup in Houdini to fix it.
Yeah, I think when you are creating texture, the best thing is to have the UVs, so that to make sure that when the object or when the model like deform later, the UVs, the materials are still sticking onto it. Yeah, so I think the UVs are important. We have also created some new UV tools that can help you create UVs. I forgot the name off the top of my head. There's a new one in 21 where we scatter a bunch of points, and from the points, they sort of grow into different islands, and that are like the different the different UV patches. Yeah, so there are still some procedural ways that you can use to unwrap or to create UVs for your object.
Thank you.
Thank you.
Hey, mate.
Hey.
The shot management stuff that you went through is really, really interesting. For a bigger studio that I know you mentioned that it's in beta and it's mostly for a smaller studio without a pipeline. For a bigger studio where we do have our own folder structures, our own asset resolvers, all that kind of thing, is there any way that we can still hook into that shot management pipeline in terms of being able to have our different shot contexts using that shot split thing that you showed without having the JSON file and it create the folders and things? Is that possible at all?
Yes, yes. So the shot edit layer, I think that's usable with any pipeline, because the shot edit layer just points to a USD layer that you can edit, and then the shot split inside is just a bunch of expressions to split it up. So you just need to figure out how the expression sort of work with your studio's file directory structure.
And that the UI that you showed with the tree of all the different, like we had the animation layout, whatever, and the USD files in that, are we able to set that up without using the JSON file that you showed? Oh, that's awesome. Thank you.
That's just automatic. The shot load brings in all the data, and each one of them is just setting up or targeting the different USD layers. Yeah.
That's awesome. Thank you.
Cool.
Hi, Adam.
Hey.
Thank you for the great presentation. One of my favorite features for Houdini 21 is the ability to incorporate Metahuman into Houdini. And one of the most powerful features of Metahuman is the facial capture performance. I was wondering that if the new tool be able to import that data into Houdini, and then we can do further tweaking inside Houdini, because my workflow for Houdini 20.5 is that I have to export that data out as FBX and then import into Houdini, and then that's the only way I can figure out so far.
Okay.
So yeah.
Yeah. So I haven't tried it out personally yet. I know the rigs are automatic. I mean, like the rigs are compatible both sides, but I'm not sure in terms of the keyframe animation, like if you are able to bring that across. Yeah, I think that's something that I need to test, you need to test to figure out. Because the plugin just got released a few days ago. Yeah.
Yep, awesome, thank you.
Hi there.
Hello.
Just a quick one. On the COPS cables edition you mentioned, do you know if they're able to be loaded into OpenCL nodes?
Let me see. I think if you... I can't guarantee it, because off the top of my head, I can't think of any, like what's the signature to bring like a cable in. Yeah, I'm not sure, and I need to find out. Yeah.
Okay, thanks.
In the back.
Hey, that was great, thanks. Is there one day a world where I don't need Nuke and can just do all my compositing in Houdini?
Yes, I think, okay, so right now we can't really say that COPS is a full compositor because we are missing the time functions, right? So right now, COPS have no concept of time. So you can't do any time shift or you can't do any time warp. So we need to put stuff like that in, maybe like some features for roto and other things, yeah. But it's coming in the future, so just be patient.
So one day?
Yes, one day. Yeah.
Anyone else? Maybe one last question? Or if you want to chat with Adam this evening, I'm sure Adam will be happy to answer more Houdini questions.
Yep.
Or Ben? Maybe? Pick Adam. Thank you, Adam. Please put your hands together one more time for Adam. So as always, got a few things to give away, a few offers to announce. First up, we're going to give away a couple of Houdini indie licenses. Did everyone grab a ticket on the way in? We'll come back to that one maybe. We'll come back to the Houdini indie licenses. We've got a couple of offers from a few places just to let you know about. One is from Fox Render Farm. If you're interested in doing any cloud rendering, you can sign up. Apparently you get a $25 credit on registration, and if you use this link, which of course is really easy to remember, so I'll email that to you, you get a $50 credit for using that link. If you're interested in learning Houdini, you can find Houdini courses and tutorials at hitplus.how, and you can use this code SIDHUGBIN25. Again, that'll be emailed to you. You can use that for the next 30 days, and you can take 20% off any of the courses or bundles on the site there. And then Wacom. Thank you, Wacom, for being such faithful and loyal supporters of SIDHUG. We're very grateful for that. This evening we have a Wacom Intuos tablet, one of the latest ones to give away. As soon as we have our raffle tickets ready to go, we'll do that. We'll go. Adam, would you be kind enough to draw a winner of a Houdini indie license, please? This is a purple C27. Oh, well done. If you maybe just have a chat with Ben, and Ben can grab your details. And then we have another of those to give away. Would you mind? Oh, yeah. Thank you, Ben.
A36.
Orange A36. Thank you. Josh, would you be kind enough to draw a winner of a Wacom Intuos tablet?
A34 orange.
Cosimo, congratulations. Congrats, Cosmo. If you weren't lucky enough to win one this evening, you can still get 20% off using this code AQ Tablet, or 15% off a display. Again, you'll find those in your inbox in the next few days. And that's it for this part of the evening. Please stay, have a drink, have a chat, and I look forward to seeing you at the next one. Thank you.